¿Sigue estando allí o...? No, salió, ¿verdad?
Sí, no lo veo.
Ahí, espera, yo lo admito. Ahí está tratando de entrar.
Ahí está.
No, ya está, ya lo admití. A ver.
No, sale sin el sonido.
¿Sigue estando allí o...?
Hola, ahora sí les escucho.
Ok.
Estupendo.
Pero está saliendo... Ahí, espera, yo lo admito. Está saliendo por... no, estoy escuchando...
Doble. No, sale sin el sonido.
Yo estoy escuchando dos salidas.
Hola, ahora sí les escucho.
Ok.
Estupendo.
Pero está saliendo por... Ahí, espera, yo lo admito.
No
Ok,
sé
ya.
si necesito poner audífonos para que no oigan el eco. ¿Puede hacer eso?
No, ya está bien, ya está bien.
Listo.
Sí, creo que es porque, bueno, ya vamos a empezar en 3 minutitos.
Listo.
Entonces, Nico, aquí yo te voy pasando diapositivas para mencionar pues los sponsors, un poquito de las charlas que tendremos hoy, 2 charlas invitadas, 10 contribuciones, visitar los pósters y controlar el tiempo. Y esencialmente ya invitamos a la gente a quedarse en todo el programa y le das la palabra a Beatriz, que va a presentar al primer invitado.
Ya, perfecto.
Perfecto. Bueno, voy a darle paso a los invitados, a los participantes y comenzamos en 3 minutitos, si les parece. Ahí está el relojito.
Hello, everyone. Good morning.
Hello, madam.
Good morning.
How are you?
Hi, madam.
Good morning.
I'm fine. How are you?
Very
Fine,
good.
thank you. And you?
Hello, everyone.
So we are going.
Today is going to be the final day of our meeting. How are you?
Good morning.
How are you?
Hi, madam.
Good morning. Thank you. And you?
We are going to start in about 1 minute, so thanks for joining.
Yeah. Hey, this is Santiago. I'm not able to see any of you. Hello.
Yes, we can hear you. We are just waiting for a few seconds, but now we are already live streaming the session, so you can also share the YouTube channel if you want someone to be able to watch the conferences.
Yeah, Santiago, I'm not able to see any of you. I mean, could you solve this problem?
Yeah, no, I at the moment I have my camera switched off, so
That's okay, but
No
then
problem.
what about others? Hi, Gracia, how are you? Gracia, do you hear me? Oh no, something has gone wrong. Okay, right.
okay, Nicolas, if you want, we can start. Thank you.
Where do I look at you people? I mean, you people are totally invisible to me. It's like, dark matter which is preventing me from looking at you.
Good morning, everybody. Thank you for coming to the second day of the workshop on astronomy beyond the common senses for accessibility and inclusion. I am Nicolás Vázquez from Escuela Política Nacional, and also currently I am collaborating with the Andean Regional Office of Astronomy for Development. And we'll continue this the second day of the workshop, which being supported for those institutions you can see there. We want to develop or make conscience about the importance of accessibility and inclusion. And here the second day of the workshop. This workshop aims to know what we're working on. This interdisciplinary meeting. We will see astronomers, educators, and disability specialists to talk about their work. Don't forget, the workshop will be streaming on YouTube. Please, you can see the link below in the screen. Please don't forget that. And today we will have 2 invited talks. The presentation takes 30 minutes with 15 minutes of questions and answers, and 10 contributed talks. Each one has 12 minutes for the presentation and about 3 minutes for question and answers. Don't forget to visit the poster exhibition also in the same web of the workshop. Here's the link. And the moderator will send you these advices. When the time you have for the presentations, you will have an alert 2 minutes when you have 2 minutes left, and a red one when the time is up. Here is we have around 5 hours of presentations that were going to be very interesting talks, and please stay with us, and these are the posters we will talk about at the end of the. I hope we can have a little time to talk about what we learned in the closing of the workshop around 9 GMT. Welcome again, everybody, and we are waiting for our first speakers. Maybe I think I will now give the talk to Beatriz, who will be conduct the sessions today. Hello, Beatriz. Welcome.
Hello.
Thank you for
Thank you. Thank
collaborating
you,
with us.
Yes, always. Thank you for the introduction, and we invite you to the first talk by Stavros Katsanevas. To me, it's a pleasure and a real honor to have this invited speaker here. Stavros is a professor at the University of Paris-Diderot and the director of the European Gravitational Observatory, and since 2018. He has served as director of the Laboratory of Astroparticle Physics and Cosmology, and co-director of the Laboratory of Excellence University Earth. And he was a member of a lot of collaboration, European collaboration and international collaborations. But for this special, in this special moment, for us, he is the coordinator of one of our sponsors and organizers, the Reinforce program, which is a very important citizen science project, which join several programs, several international programs, and I am sure that Stavros will describe better than me. So thank you, Stavros, to be here, and the stage is yours for your talk, from the sublime to the beautiful. An excellent title. Thank you very much.
Yeah. Thank you very much, Beatriz, for this invitation. It is something that we are doing together, and I really enjoy enormously. And so let me, first of all, explain my title. You know, in Kantian philosophy, sublime is the things that you can only see, and they are so far that you cannot have any other feeling with them, and to produce some terror from time to time, surprise, terror. This is the sublime. But the beautiful is something that's inside, it's close by. You can not only see it, you can hear it, you can touch it, you can feel it, etc. And that's the beautiful. So I would say that that's how astronomy and astrophysics moved from the faraway stars that were sublime and fascinated the humanity so many years, to starting to feel at home somehow. Of course, still it's quite far, but at home with the multi-messenger and the multi-sensorial possibilities that this opens up. That's therefore my introduction. And here I would make the publicity of 9 posters we have, and I will have to find a way to quantify them. And the first one is a possibility.
Recording in progress.
That, you can, grosso modo, divide the images of the sky in 3. The one of the constellations, the mythic one. Then how we saw the universe as a geometric universe, where you would see light points moving around in a dynamic fashion. You can say this is from Thales to, let's say, Galileo, Newton, etc. And the recent universe, where we see it is again a landscape. It starts to reminding of constellations because it's full of dark and violent phenomena that we try to measure with our detectors. So, I'm a funny introduction. I mean, the different senses is an old story. Of course, Zeus communicated with the people with Hermes, but also dawn, lightning, and rainbow were his messengers. And then the pre-Socratic philosophers that tried to sense the universe, to perceive the universe, they were, let's say, biased with different kinds of messengers. For instance, Thales, to measure the pyramid, used light and shadow. Then, of course, Pythagoras, as everybody knows, used rhythm. I'm sorry for the error. Rhythm and harmony. And then Democritus was the most extreme. He said in order to interact, you have to touch. And that's for atoms and vacuum, atoms moving inside the vacuum. These days, we try to use all three kinds of organization of the universe. And that's what I will try to show. Then, of course, I thought I had a little bit more time. But anyway, you know the story. We tried for a long time to find a rhythmic universe. Kepler was still on it. Then Galileo was more. Actually, there is a funny story that he was influenced also by tennis. That was important at that time, the trajectories. So trajectories inside the space was his thing. And then Newton gave the laws of gravity, where he said that space is an immobile sort of framework within which objects move. And then when they told him, okay, your gravity laws, where are they based? He said, I don't know. Hypothesis non fingo. Then we had, of course, Maxwell, electromagnetic waves that in the beginning were thought as the formations of some liquid, we could say ether inside space, but then we discovered with the Michelson-Morley experiment that it was actually electromagnetic waves were propagated into the vacuum, which is very interesting and again gave a new view of the universe. And of course, in the late 20th century and the beginning of this one, photons of high energy, neutrinos of high energy, and high energy cosmic rays, not to say about the gravitational waves that I mentioned already, have become new messengers. So this slide says exactly the same thing I said in the previous slide. The fixed time that Newton had in mind and the empty time, the empty place that Maxwell was finally, the electromagnetic waves of Maxwell were moving. Then comes the Einstein's theory of gravity that says that space-time is a deformable medium. Therefore, when you have, I'm sorry, I thought I had a big something moving, but it's not moving. Anyway, when you have a collision, for instance, of two black holes, this is so violent that deforms space around it and makes waves, by the way we have waves. Lucky for all of us, the relationship between space-time and the mass energy that produces the waves, it is 10 to the minus 43. So the space-time is not, it's a difficult thing, first of all, to detect the gravitational wave phenomena, and let's say that the 10 to the minus 3 is delta L over L. So that is how a distance between two objects that are in free fall changes by a gravitational wave, the constants. So you see that it is very small, and you have to have, before saying that, is a big problem. Once he discovered that, was to see how the heck this thing will interact with matter. And only in 1957 we had idea, or what I just said, that a gravitational wave passes, let's say this is a classic bead on argument where you have two little circles, there are cylinders moving on a rod, and then you see the gravitational wave passing just makes these two cylinders oscillate. This was the idea of Pirani, but also of Feynman. Okay, so can we try to be Marconis of gravitational waves? Again, it doesn't, I'm sorry, it doesn't move. Why it doesn't move, I don't know. I hope it's not repeated. If you get in your room and you take two things of one tone and you make them run one around the other, the final change of distance it would have in any object around it would be 10 to the minus 35. Again, very much away from what we can detect. But if you go up in the sky, then you take 3 black holes of 30 solar masses, and you have them turn around each other at a distance of 100 kilometers, nothing, and a frequency of 100 hertz, you get a delta L over L, this perturbation of 10 to the minus 21. And strange as it seems, this is something we can detect, is 1,000th of the diameter of a proton. And what are the sources that you have in gravitational waves? This coalescing binary system, 2 black holes, a neutron star, 2 neutron stars, a black hole and a neutron star. Continuous sources, a spinning neutron star that is slightly asymmetric. And then you have these forms, these above forms, you can have a template. You can know how it is. I mean, you have the form of it. But then you have things, a supernova exploding, where you don't know the form because we don't know yet what is the physics of a supernova. Or you can have events, every violent event in the universe emits gravitational wave. And you see that this is a big asset. So, here again, the posters, of course, sorry, I have 2 or 3 slides in French. The life and death of stars. Actually, Wanda is making a very nice course, Wanda Diaz-Merced, that you probably all know. Makes a very nice course on the life and death of stars. She made it on Harvard. We hope to make it also here in Pisa. And the end of the stars are black holes, neutron stars, or white dwarfs. And this is not all. You have the mergers, which I said. We have blazars, pulsars, supernova, bursts of energy, tidal effects, fast radio bursts. All of these can be detected not only with gravitational waves, but also by photons, neutrinos, cosmic ray particles, and what have you. So if you take all this, you find let's say, what, according to me, are the mysteries of today's cosmology. It's inflation, how the universe started, dark matter and energy, why 95% of the universe is filled with dark matter and energy. Why? Then the other 5%, it's even another mystery, why it's matter and not antimatter, because we know from inflation they will produce in equal quantities. So when we say we know the standard model of the universe, we know exactly what we don't know, how matter dominated antimatter, dark matter and dark energy. And then, of course, formation, evolution of galaxies, the role of violent phenomena, the nature of black holes, neutron stars, and white dwarfs. It's a fantastic thing because we know that they exist, we've measured them, we've seen them, but exactly how they are formed, their equation of state, is not yet something we master. And of course, physics of dense matter and strong electromagnetic fields, and the coherence between the infinitely small and the infinitely large gravitational waves in quantum mechanics. Starting now to the sonification part, let's say, it's an anecdote. When Penzias Wilson discovered the cosmological Mach-wave background, the literature guy that had the Nobel Prize at the time said, it's you that have heard the Big Bang. So they went back home and they put their radio signal, they put it into sound. They transformed it into sound, and that's what was it. What we just heard is a soundification we made here in EGO, where we sonify the acoustic, because there are acoustic fluctuations of the chronological background that were discovered with our friends Smoot and Mather, and you see, you can have a map, but it is a map of fluctuations, but also a map of tones, and that's how it would look. It is done by Jeff now, a guy that Beatrice also studied with. So let me move to the next one. Come now to our Virgo interferometer, which is a 3 by 3 kilometer object. And it's in Pisa, and you know Pisa for her tower. It's been a very long story, 30 years in the making. You can see me, even myself, very young there. Recently, we were recognized as an IEEE historical milestone of technology because we saw the gravitational waves. And I reminded you what we saw. Before that, let me give you the image of our interferometer. We have a laser that is split in the middle mirror, and in two branches. And the two, of course, it is a Fabry-Perot cavity because it means it has the light goes back and forth. The 3 kilometers are multiplied by 400 through the coming back and forth of the light over the two mirrors. And at the end, they are as you can see below, they either come in phase, the two come in phase, and actually in the normal operation, we make that the two waves come in phase, and when a gravitational wave that is transversal, it changes the distances of the two arms. Of course, they take them out of phase, and where you were at what we say dark fringe, that is light on light was darkness, you start seeing some light. Of course, it's never darkness because you always have noise, and the noise will make it change it. And of course, then whatever you have, you make a Fourier analysis of this style, and you get a plot, frequency versus the noise. And there are three fronts that we look at. One is in low frequencies. The first thing I want has to say it is that the frequencies are from 10 hertz to 10 kilohertz, the acoustic band. We can put directly our signal to a microphone and you'll hear the sound of the universe. That's the joke we say. Pascal used to be afraid. He said, the silence of these eternal spaces frightens me. So we tell him, don't be afraid. Pascal, we've heard the universe and there is a noise. And black holes and neutron stars and all the rest. So in the low frequencies, we are in the environmental noise, up to, let's say, 20, 30 hertz. And this is where comes a lot of potential for us to interact with the Earth things, with the passage of the seismic activity, the passage of the clouds, passage of anthropogenic noise, the sea, the impact of the sea on us, etc., etc. Then in the middle frequencies, around 100 to 200, you have the thermal noise, the mirrors. Their mirrors, as they move through temperature, gives you noise, and then at the end you have very few photons and high energy, and that makes us fight against quantum noise with a lot of technology, which I don't have the time to go through because I want to go really to the things that are interested today. We the other day thought of to make a sound interferometer where you would put 100 hertz in two different megaphones. I'm sorry. Not everything is shown. I don't know why. Yeah, you put them there, and then you go to an equal distance, and they can neutralize one each other. And then when they are exactly the same distance, you hear it. A good sound. If you move 1 meter left or 1 meter right, you'll start seeing silence or all the things that happen. So something that we will try to implement here so that everybody can sense what is this interferometer also in sound. And then, of course, the big event was the 14th September of 2015. The two black holes collided, and they gave the sound you just heard, which is, again, between 30 and 500 hertz. And you see on the left, you would see the form. And the form, as I said, when there are two black holes, for instance, we know exactly what form they have to take. And this is what we saw. You also see something I will tell later on, that when these things pass from the Earth, for instance, the Earth vibrates. But of course, you cannot see it because of gravitational waves. Of seismic waves. Okay, that was one thing. So here is a plot where it shows the form and what the information this form brings. It brings the frequency evolution of the inspiral, the masses, where they are, the distance they are, and many other information. Of course, sometimes not exactly alone, you have to disentangle things. And then something that was fantastic is in 17th of August of 2017, we saw two neutron stars colliding, and this was not only in gravitational waves, we saw it in X-rays, and then we very fast, we were three interferometers operating, LIGO, the two LIGOs in Virgo. We found a place in the sky, and then the astronomer friends, 70 observatories around the world, found out the galaxy that this thing happened. And then we were able to follow how the light coming from there evolved from blue to red. Again, this is subject to sonification. It's a fantastic thing to be able to measure something that happened. I don't know, I keep forgetting the millions. 150 million, I mean, it was not megaparsecs, it was 40. Yeah, I think 150,000 million light years ago, being able to see it second by second. That's a fantastic thing. So it's that's what we got. And this brought us an enormous amount of information on how the nuclei are formed, information on cosmology and on how the Hubble constant changes, the density of nuclear matter, and what have you. These days, we are at 90 events. We just published it 3-4 days ago. And when we were running, we are not running right now, we're upgrading the detector, we would see one event per week. And this is, again, a plot that I would like to sonify, just pushing, I mean, I saw ideas in the previous, pushing, for instance, or touching each of these black holes. At least the first thing you can do is hear the spiral noise, the spiral sound as it came in. So this is not the end. We will reach at the end towards 2 events per day. So it's a perfect astronomy object. And then something else that I have to say, I talked about the inflation at the beginning, and I have to repeat here that every event that is a phase transition or a violent event, some kind of string or kinks of the matter to matter domination transitions, the nucleosynthesis transitions, the quark and hadron transition before the recombination world that you probably know at 400,000 years, all the matter became neutral, therefore the universe could start. Before that, it was in a plasma phase. All the events that happen in the plasma phase with gravitation, they are violent events. And being violent events, you can detect them with gravitational wave. And this is a big hope that we will see cosmology. And of course, we will also see all the visible universe, starting from the 400,000 years of the, let's say, recombination world, till the 14 billion years of today, that we have the galaxies and the stars as we know. And actually, it is right now we see up to redshift of 2, and we'll go up to redshift of 100 with the third generation. So I mean, again, it is not the same thing that we're seeing all the time. The third generation, if it is on Earth, it is always 10 to 10 kilohertz. Then you have in the space, you see different frequencies. You go down to the -4 hertz, and that means you see other kinds of black holes, the black holes that are at the center of the galaxies, and that's a very interesting thing. And the thing that is missing, and that's another program I like, and I just mentioned it here, is ideas to go to the moon, and through the vibration of the moon that has only the seismicity 3 orders of magnitude less, be able to see how a stellar mass supernova up to, let's say, 150 solar masses, supernova turns to a supernova that is very, very big, let's say 1 million solar masses. And all this will be becoming a very interesting topic of research, what called EMBH, intermediate mass black holes, that we will probe with this. We had recently a very nice workshop, and you have here you can hear many things happening, even some art things. Why go to the moon? I don't want to spend time because I want to go to the things I want to tell you, but I want to show you first the science and then go to the art part. So why go to the moon? Because I said no atmospheric effect, no seismicity. Because it's far, you can localize where the signal is coming better. You can analyze in multiple frequencies and all that. And the first idea we had is simply deploy on the moon two arms of fiber, good fiber that is well put on the surface of the moon, sensing the vibration of the moon. And we think, all the technology. There's difficult things also. Of course, it's not something that we can, because, for instance, the sun changes very often. The seismicity, it starts moving, deforms, the temperature deforms the space, and that's one of the problems we have, energy problems, etc., etc. So what I just said, we have three complementary, and you see that Earth, Moon, and space, and you see that they all go to redshifts that are quite 1,000, the beginning of the visible universe. And also, as I said, beyond that. So we made also something that I think we have to make, again, something about sonification. We made a wavelength piano that starts from one hit per the story of the universe, a La that was said, it's an Om, you might say in Indian, Om that starts in the beginning of the universe, one per the life of the universe, to a frequency that it is what is called the Planck energy frequency, which is many. And you see that you have many maps, and the new things that will come to us will be how we will compare the different maps with the different probes, which are gravitational waves, optical telescopes, electromagnetic telescopes, radio, neutrino detectors, and all that. And you see the acoustic, the visible, all the senses, I would say all the frequencies, will gather them together. And this is a big tendency of modern, let's say, astrophysics. And that would give us access. Another poster, I will not go because I said of the problems that we are searching. So gravitational wave has an impact on all fundamental science. I've said that again and again. I will not go through, but I want to go now to the things that come with it. And I call it always the four cosmos. Not only understanding the universe, understand where we are in the thin place we are, 10 kilometers above the surface of the Earth and 10 kilometers below the surface of the Earth. This is where we're living, the surface we're living, and we use it, as you see, you understood, we use it to see the cosmos. We have it. We need all these astroparticles. They are embedded into the climate. So climate change, alerts, and all that is our work. Multi-messenger physics then immediately brings to mind multisensoriality, as I said from the beginning. With multiple senses, we can see the universe. We thought that the domination of the visual should go away. And also something else that comes is a little bit more philosophical. We thought that the senses were secondary with respect to space-time and matter. Probably we have to rethink that, because probably senses play a role. Each sense creates a proper space. And of course, all this is matter for education, citizen science, art and science. So I said about it, I said that everything impacts on our detection. We have to understand the sea waves, they hit the nearby shore, 15 kilometers from here, and they make noise to us. And we discuss with ecologists, because climate change increases the impact of the sea waves and increases erosion. Seismic noise, we can have seismic alerts, radio waves, electromagnetic waves, cosmic rays, and even the atmospheric, the clouds that pass, they have mass, and the mass changes the position of the mirrors, and we have to monitor it. And this can be also a predictor of some natural catastrophe. We have developed a worldwide low latency alert system. In 1 minute, can say to everybody that we saw a gravitational wave, and so we compare around the Earth. Why not use this also for natural catastrophes? For instance, an example is we have 1 kilometer fiber network that we deployed, and with it, we can use it to see how sound goes around this 3 by 3 kilometer object, this interferometer, and we can, by having these fibers, every 10 meters is a different acoustic sensors. We can make an acoustic camera and then isolate even where the sound comes from. So all this, I let you imagine how we would be able to use in let's say, Earth, climate and things. So we have also a very, very rich program of from art and science, citizen science, of course, together with Beatrice. And a few things I want to say. So the common platform we use is Universe, as well known, 1 million volunteers. Our gravitational waves are part of it. We have also the Deep Sea Hunters, which is deep depth of neutrinos at the depth of the sea. We have a CERN program and cosmic ray program looking at the volcanoes. And there you can get in and help the science to classify things. You've heard a very nice talk by Massimo before, Maximiliano, excuse me, Max Alzano. We have, beyond the help of Beatrice, we have also Wanda Diaz-Merced, since March 2021, helping us. And here is, he did not manage to show Maxime that you can have what we call a glitch. A glitch is a signal that we don't understand. And then it can be, most of the time it's a technical signal, it's not a signal from the cosmos. And we will also sonify it with Sonuno, for instance. And by sonifying it, and we can give this to people to try to classify it with respect to sound, classify it with respect to light, and then we have a two-dimensional thing. We see who does it better, and we see how we can get it better if we add the two. So this is a paper that's very interesting to me. And always our ideology is not that we do that for increasing inclusion. We also believe that by using both senses, we will increase the way we understand the world. And that's so it's epistemological at the same time of inclusion. So we have the courses, of course, one that gives courses to Harvard, and then we have, starting next year, we have links with the UN, etc., etc. So this was done yesterday. There was, Max presented that. I don't go through it more. Again, I think he did not manage to show this. And I have it. It is, of course, you have the options to sonify it in different ways, and that's how we do it. The other thing we do is at the bottom of the sea. In the bottom of the sea, you have two things. You have neutrinos, but you have bioluminescence. And that can be background to you. And this, you see here how you would identify, I'm sorry, why it moves and so on. You come on. So you can identify peaks that are due to light, but also you have acoustic detection. In the acoustic detection, of course, the dolphins and cetaceans in general, the whales make noise. So it's very fun. They have 25 years of signals that are certainly given by cetaceans, and they have 25 years of bioluminescence. And I wanted to show you something that it isn't from now. Yeah, this is an image of a neutrino passing through the detector and leaving light in all the detectors. And that's how we detect a neutrino pass. And where bioluminescence is a background, and I will show you with a very fine camera, sensing one photon. You see it's completely dark, and suddenly you see a little thing start emitting light, and this again we have to sonify. And then the funny thing about it is that around, let me go faster, run around a second guy comes, or guy or gal, I don't know, they start discussing. They are 1 millimeter objects, these things, and they're discussing, what are they saying? God knows. So we will want to also sonify these things. We will get down to two cameras, very sensitive, and see how they move in space at the same time. The biology, things that the biologists, when we show them, they have never seen them. This happens at 3,000 kilometers below the surface of the Earth. And you know very well that the bio things that are in the sea, they are much more than what we are. And the other one is about cosmic rays. I will not say anything about cosmic rays because I want to arrive to where I can stop wherever you want. We made also, all this is of course something about art and science, very interesting. We have a good friend called Thomas Saraceno, who is an Argentinian, of course, and he also likes a lot of spiders. It's among the 10 best artists in the world, written in and who has created this space, also with our help, because they are gravitational wave sounds sometimes, where you enter and you touch some strings, and by touching the string, you are embedded in a space, and you leave the space by touching the screens. That's one way. The other thing we did was, I stopped this. The other thing we did is here you are inside our detectors, all this, and there was a lady, and also with her husband, they played music, and the music, we registered it directly with gravitational waves, because as I said, every sound creates for us noise. This was not noise, this was a work of art. And then in the passage of the new year, this year, we together with Saraceno, I hope it is visible, we made this arachnophilia. I don't know how much time I have to present what Barry Barish, the Nobel Prize, said.
What we do is study the rhythms of the universe. Gravitational waves, which is what I'm known for, and something predicted by Einstein a little more than 100 years ago, have produced all kinds of sounds of the universe. And we heard the particular sound of the collision of two black holes.
So I stop it because it is very interesting, and I want to show you something else also in the same place. I invite you to go. We made it together with Barry and also the Saraceno, and that's the most fantastic thing is the trailer where Saraceno registered how there you have to have earphones to understand how spider understands the world by touching things and how it moves. I don't know if you can hear the sound. And his theory is that we should imitate the way animals sense the world globally. So there was a discussion we made. I don't want to go through it further. It's just publicity that you go and see it, and it's fun, I think. And then we made this exhibition. These are the final slides I have. An exhibition we'll call the Rhythm of Space here in Pisa. For instance, again, let me use, I skip my introduction where I say a few things. Come on. For instance, it is again spiders. It's oh my God, heroes.
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new graph.
So again, how to entangle the universe in a spider web.
Here we have another characteristic.
You have a spider web illuminated by a red laser, and then you see the different parts of it, how they move, how they entangle, how they...
And especially shows a true spider web in 3 dimensions, illuminated laterally by a red laser. So the laser cuts out 2-dimensional projections of 3-dimensional space and questions the issue of how spaces fall.
Okay.
They are very advanced.
And then another one, a fantastic one, together, but again by Thomas Saraceno. It is how sound, there is sound coming from below, and then you have particles, and they start dancing and they form structure.
Where you see that you have sound coming out, and the rhythm of the sound, which is also, of course, waves of pressure, modulates dust and creates structures. You see these strings moving together. And it is a question about what is structure. It comes from dust, but it comes also from rhythm. Rhythm and dust and particle and modulation are together collaborated in order to make structure.
The children that were sitting in front of it was a fantastic thing. Touch and sound, what it is, this is, I think it is, another very interesting thing. I will not wait for, there is Spanish colleagues, they took this thing you see here, this thing you see,
producing chains for ships.
They went to an industrial place where the chains were on the ground and they deformed the iron of the ground. Then you have a work of art that you can touch, and they pass also a laser light together it, and they produce sound. So you have something like this.
On the ground, they were deforming the ground.
A deformed space by big chains, industrial chains, and how you hear it through music of another artist.
And by scanning it, follow the deformation of the ground, and then sonify. And this is the music process. The sonification of the deformation of the ground, of the power factory, chains,
etc., etc. And this is a fantastic one with Lynn, a great artist who made Gravity's Dance is called, and where you enter in this room, and once you enter, a sensor understands you enter, and you have this skirt, cosmic skirt, that starts going around, turning around, and then at the end becomes gravitational wave. That was a fantastic, it was a key work of that. I don't want to put the text with it, I just wanted to show it. And then the last one, sound and gravitation waves. Yes, I don't know if it's coded sound, I will skip. We have something we did with Beatrice, which was the cosmic rays, how you can sit in a sofa, and we had a cosmic ray detector above and below, and you would sit there and we would sonify the cosmic rays coming for Roger, for instance. No, we used the cosmic rays that were passing from the detector there, but this the idea, the first idea was Roger, of course. And then there was music, and we were sitting on the cosmic, and this, I say, if you detect cosmic rays, it is like order of the universe, because what is order? Particle entering our node. Again, I skip and skip and skip. Touching the universe, I also like a lot because it is, I think this is it, yes. This is a potter in Greek island, where with his hands made the black hole that we use in our exhibition. We have two black holes and we use them. And this is another way to reproduce the round, the spherical universe. And pottery, and of course, you have many things like that. And the last one, I will not go further. This is the black hole. And then we had all around it, we had two blackboards that were bended as it's bended through gravitational waves, through gravity and all that. So it is. So I go to my last statements because just. Yes, before going to the last statements, it was a fantastic thing that happened. It was people coming that were moving towards Alzheimer, and people usually use them to visit places so that they get alert. And they wrote this very nice poem by seeing the exhibition, saying reflection. This is in Italian, it's even better in Italian. It's called Odyssea in Space, reflection, spherical core, globe shape, black earth at night illuminated by the moon, abyss full of empty, polished, esoteric mystery, region, emotion, restlessness, oppression, cold, pupil of Polyphemus. And so they were identified by the loss of information. It's well known that when you go inside the black hole, with their personal, and this was touching for all the artists and the scientists that participated in this. So with all these dreams, we want to make a visitor center very soon. Before the end of the year, we'll have a van where we put some of the ideas, for instance, immersive van, where people going inside by their presence change the projection of the wall, and from an Euclidean space, you get a non-Euclidean space. And there we will have also Larsen machines that you would also feel it acoustically. You would change, your presence would change what you see also acoustically. So this is the idea we have, to have a laboratorio del silencio, we call it, visitor centers to the environment, technologies, learn about gravitational waves, citizen science, critical thinking, art and science, and a collaborating ecosystem with many people in the world. So this is the logic of the four worlds, of the four cosmos, where cosmos in the antiquity, which means a good order, did not mean only the universe, but meant also the earth, meant also the society, meant also the internal cosmos. And all this we try to put them together when we talk about that, because we believe that it is a gravitational wave scientific revolution. And every scientific revolution puts problems on our ideas of space-time and matter, environment, communication, society and individuality, and our awareness and use of our senses. So last, I promise, I like very much this phrase by Freeman Dyson that says the preservation of life does not depend so much on availability of energy as in the separation of signal from noise. And this is the most general problem that you might have. And so thank you for listening to my cataract talk, and so I have this too.
Well, thank you very much, Stavros. Really nice conference. I think this a lot of examples of how we can combine sonification and images and other sensations to have another interpretation of the sounds. Yeah. We have some questions, only a few questions. The first one is how does sonification predict wildfires?
How can you predict what fires?
Yes.
Fires is more difficult. I didn't say anything about fires. But anyway, you can have these TDSs, the temperature distributed sensors, that are not very expensive. You take a fiber, and each point in the fiber, every 2 meters, 3 meters, is sensitive to the difference of temperature to 0.1 Kelvin. So you can, for instance, deploy these fibers around sensible places. And then you have, you have not only one sensor, you have 1,000, you have camera, you have 1,000 sensors in kilometers. And then they would feel some change of temperature, and then you can even localize it. The way you would do with an earthquake, there is the acoustic. I'm not saying that you will hear it, but it is a vibration, infrasonic. And the way that you could do, yes, seismic or even other things like that. So that's the way. And we propose to use it, in many places, this thing. In underground labs, because they don't have a lot of seismicity. And then you can imagine that it can be a predictor. an early warning of an earthquake. Early warning is always here. It's seconds, not don't think it's minutes.
Okay, thank you very much. You also mentioned that gravitational waves has also an implication on education. Maybe you can tell us how is the impact on education and activities you do from the outreach. There is a impact that have been measured, something like that?
Yes. I don't have the numbers with me because we participated in Frontiers, another program where we were with high school teachers, and there we produced a lot of, let's say, the word I miss, let's say products that we explain gravitational waves. A big pleasure was last time we had people from Sri Lanka, girls' school, that we do virtual visits. I skipped all that. We do virtual visits where the person is live, going around the detector, and with a camera, somebody else follows him, and they discuss, and then it shows. But all this is live. I mean, it is remote as we do now, and this has a lot of interest in even countries like Sri Lanka. I mean, that are. And this, I think, we will continue again and again, and I think it will be very interesting.
Okay, our last question from Anaeli Pacheco. She asked, there is anything that surprised you about this collaboration?
Which collaboration?
The projects on art and science. I think it's all
projects of art and science. Yeah, I tell you my thing. Again, I will use a philosopher and that learned me that I think both art and science come from myth. That's why I started with the three with Zeus. And science, some kind of myth, the myth that tries to explain phenomena through the presence, acts of God. So science tries to explain the phenomena with what was logos, rationality, and things like that. A lot of it is also prediction based on what you know, what's called in jargon Bayesian thinking. Having this data, having this theory, how probable it is that this data and this theory tell me something about the universe. So that's for me rationality. Rationality is not, I know the theory, this is what it is. Rationality is always a guessing and uncertainty. And our people that are managing the pandemic, they should know about that, but they don't understand it very well. Now, the artists took up the affective part of the myth, because myth made you feel inside the world somehow. There is the affect, how it moves you, how you feel that you are inside. And so that's why I said it in the beginning, the space of Newton, it was a frozen space. The poor guy they were the Catholics and the Protestants at the time fighting like mad, and he was trying to find some strict rules of rationality to survive between the butchering of one another. Now we are, again, not in an extraordinary place, but still we're trying to find our place inside something. And so that's where the artists come from. And in the catalog we wrote about art and science, where this exhibition was said, we put a phrase by Oppenheimer, the brother of it's Frank Oppenheimer. So he said that scientists and artists are these world's noticers. They notice things that the other people cannot. And this is a common ground. I mean, I got the best, both by Barry Barish. He said this is a work of art, etc., etc. And an artist that said, I enter into a room and I don't understand it is science or is it art? Because there was some kind of continuity in the thinking of what we were doing. And that was a big pleasure, I think. And yeah, I wanted to say something else also about it, but I'm an old man, I forget what in the middle of what I have to say. But yeah, it was It's what I just said, essentially.
Okay, thank you very much again, Stavros. Really nice conference. Please don't forget that these conferences are available in our YouTube channel, and we will continue with our contributions. But first, I would like to give Beatriz Garcia from Argentina to present the next contributions. And good afternoon for everybody here from South America. That for us is already afternoon. Thank you, Stavros, again, and please we can have you again in another opportunity. Bye-bye.
Bye-bye.
Thank you, Stavros. I put in the chat some links to the rainforest and at Universe and also Arachnophilia. I was part of this. This experience was amazing. So I invite the people to join us with well, there are some invitations for the public, for the global people, and Rainforest is all the time inviting people to be part of this experience in the connection between art and science. And thank you very much, Stavros. Very, very nice talk. Excellent. Thank you very much. Well, and now we are ready. I think, yes, to invite Lynn Cominsky to give the talk about NASA Neurodiversity Network, creating inclusive informal learning opportunities across the spectrum. Lynn, are you there?
Yes, I'm here.
Okay.
It won't let me share the screen, however.
Great. Well, yes, you have your time now. Remember, see the clock, see the timing.
Well, I probably won't be able to see it once I start sharing the screen, but
I believe Santiago will put join with your image also the timing. Okay. Anyway, okay. I will alert you.
Okay, great. Well, hi, I'm Lynn Cominsky. I'm from Sonoma State University, which is in Northern California, in the wine country, north of San Francisco. And I am very excited to tell you about our latest project. This is part of NASA's Science Activation Program, and we call ourselves N3, which stands for NASA's Neurodiversity Network. And there's the website there for anybody that would like to check out all the resources that we have. So the goals of our program, which we've now started 1 year ago, so we're just finishing our first year, is to provide a pathway to NASA participation in STEM employment for neurodiverse learners with a focus on those on the autism spectrum. Now, this program was started because I was very inspired by working with a particular physics major at my university named Alex. And really, I've modeled the program to follow the trajectory that Alex took from the time he first came in with his mom, and he was just starting community college, and he didn't really talk much to people that he didn't know, to the journey that he took through the next 5 years. He's now graduated from Sonoma State with a degree in physics, and he's in graduate school studying material science and physics at UC Irvine. So I thought, well, if Alex can do this, why not try to make these same kinds of opportunities available to other students with similar talents? And before the N3 project, NASA had never really developed any projects that were aimed specifically at autistic learners. And so we want to improve the scientific literacy for this underserved population by engaging them in authentic NASA experiences. And a key goal is to have internships that partner rising high school seniors, so the summer between the junior and senior year of high school, with NASA subject matter experts to do research projects. And I will tell you more about that later. the main core principle of our program is based on the autism self-advocacy movement, nothing for us or about us without us. So we don't just decide what's best for these autistic students. Instead, we include them in everything that we're doing with respect to redeveloping the NASA resources, and of course in the internship program. Here are the other people that are involved. I'm the PI of the 5-year project. My associate director at Eddie on STEM Learning at Sonoma State, Dr. Laura Pedicolis, is a co-investigator, as is Dr. Wendy Martin from the Education Development Corporation and Sylvia Perez from the New York Hall of Science. We also have Dr. Ariana Riccio, who's a research psychologist, and Naomi Hoopert, also from EDC, Georgette Williams, also from NYSCI. And a huge amount of work was done in this first year by Dr. Brian Mendez to develop some of our remote astronomy activities. We also, of course, have an independent evaluation team at WestEd, Dr. Andrew Grillo-Hill and Joshua Valcarcel. So one of the main things that we did this past year was co-design with autistic students. So we involved 4 partner high schools to test out a remote astronomy curriculum that was drafted by Dr. Brian Mendez. And we started with basic photometry activities using NASA's micro observatory, small 5 to 6 inch telescopes that are run by folks at the Harvard Smithsonian Center for Astrophysics. And then once the students learn the basics of how to acquire images and analyze the data, they can move on to use our telescope, GORT, which is the image that's shown here. That's GORT, stands for Gamma Ray Optical Robotic Telescope. And we have a website, Astronomy from Home, where you can do more sophisticated photometry analysis. Now, this past year, all of our redevelopment work was done remotely with the teachers, but the teachers were in person with the students, but they could use the telescopes remotely because, you know, COVID. Next year, we hope to do much more hands-on redevelopment. In particular, the model rocketry and Arduino payload development program that I originally created for the Rising Data minority community college curriculum, which also included drones. But we're going to be doing the rocket and the Arduino part in the high school classrooms. These are specialized high schools that deal with neurodiverse learners. This is a screenshot of our Astronomy from Home website. And the discovery activities that we piloted with these students are located in this link right here. So if you want to go try them out yourself, you're certainly welcome to do so. They're a lot of fun. We have games, we have tutorials that teach how to do photometry, and then you can request time on our telescope. This is all totally free, of course, because it's from NASA. So the way the co-design process worked for these high school resources was we met with teachers and students that had already gone through the original draft of the material, and then we went through every single classroom activity, how the teachers adapted them, what the students thought about them, and came up with areas of improvement. And it was really important to hear the student voices to see what it was that most interested them, what it was that puzzled them or challenged them. And of course, this is all evaluated, and the evaluation went really well. There, of course, were challenges for some of the instructors, but the revisions that we're going to do now as a result of this co-design process includes adding an overall storyline, a pacing guide, equipment lists, things like that. I think the students really enjoyed it, and they just wanted a few more hands-on activities and not quite as much time spent in front of the computer. So the co-design process will continue at the New York Hall of Science, where we're going to choose some of the activities from the remote astronomy curriculum and drop them down to the middle school level and pilot these at the New York Hall of Science for museum audiences. In particular, we're going to have a free 5-day camp in February for autistic middle school students, and we're going to see how well most of the hands-on activities work with these students. If you know people in the New York area that are be involved in getting involved in this co-design process, please let me know. I know this is an international audience, so maybe not that many people here from New York City. So the next thing I want to tell you about is our internship program. So we just completed that. This was a summer internship program. And the idea was that the selected interns would do the equivalent of 1 month of full-time work over a 2-month time period. All of these internships were virtual, and the interns were paid $1,000 after they completed making their final presentations. These happened in September. And we spent a lot of time really carefully pairing the interns with NASA subject matter experts, depending on the individual's demographics, but also the individual's scientific area of special interest. And so we were able to span most of the fields in NASA's Science Mission Directorate: astrobiology, astrophysics, earth and environmental science, heliophysics, and planetary science, with the 16 interns that we supported. Our goal was to support 10 interns, and we didn't really widely advertise the program last year, and we were just thrilled by the quality of the applicants that we received. So we managed to expand it to 16 interns, and they did fantastic projects. The Zoom videos of all of these projects presentations are on our website that you can see. And I think I have time to show you this very short video. I hope the sound will come through.
Are you trying to share something? Hello? Hello?
So I apologize if the sound didn't work. I don't know how to fix that exactly.
You need to share the sound.
Yeah. Should I try? I looked for the thing to share the sound and I couldn't find it. Okay. So I guess I'll just continue because I'm almost out of time.
Okay.
But now I have to find my share screen thing again. So hopefully I can find it. In any event, you can watch the video yourself at the link that's on our website. So I'm sorry that the sound didn't work. At least it was a short video. Okay, so we also evaluated the mentors. We trained the mentors in special training provided by our partners at the New York Hall of Science. We gave them special training on how to work with neurodiverse youth, and that was very helpful. So we continue to train the mentors and our team members in future years with this specialized training, because it really is a totally different kind of experience working with people who can be extremely good in the area of their special interest, but have challenges in other areas of their lives, like executive functioning. We're also evaluating the internships themselves, and the report for that was just released, and I haven't quite had time to read it. But the interns certainly wanted more hands-on resources and more meetings with their mentors and information about career pathways. we're going to be opening up the application process to United States residents starting in January. And then this applications will close in March, and we will pick at least 10 interns for next summer. Please check out our Astronomy from Home discovery activities, and we will be posting the redesigned resources on our website as they become available. So please keep checking back with the N3 website, and feel free to send me any questions that you have about the program. Thank you.
Okay,
and I know there were some questions.
Thank you very much, Lynn. Yeah. Yes, a nice talk. Thank you very much. Well, we have time for the questions. Please, or raise your hand, or put the question.
There's one question in the chat about other opportunities for autistic students that are interested in physics but with limited math skills. We had a wide range of projects for the interns this past summer. For example, a video which you couldn't hear the sound on, the narration was actually done by one of our interns who's really into videos, and he's made several videos, including one for his project. So not all the projects were mathematical. Some involved hardware, some involved computer programming, some involved learning how to analyze data. So depending on the students that we select, we also then try to pick a project that will really work for their special interests.
Now, is there any, are the remote telescopes accessible to everyone?
I don't think I quite understood that, but it seemed to be a question about telescope accessibility.
Yeah.
So GORT can be used by anybody that knows how to use the software. It runs ACP. We're currently setting up a web page so that people can request time. It's very undersubscribed. It's only a 14-inch telescope, but it can do good variable star work. We're looking at transiting exoplanets as part of the Exoplanet Watch, another NASA program. So if you're interested in using GORT, just shoot me some email and we'll see if we can get you hooked up.
Yeah, thank you.
Okay, thank you, Lynn. You have some expressions of congratulations in the chat, so thank you very much, and see you next time. I will invite now to the next talk, which will be performed by Amelia María Bayo Arán. Is about the key to facilitate the inclusive teaching of astronomy. Amelia, are you there?
Yes, I'm here. Can you hear me?
Hello?
Yes, I can hear you. Yeah.
Okay.
Oh, okay.
Great.
Okay. Great, Amelia. Well,
hello. Yes, 1 second. Sorry. And now you can see my slides?
Yes.
Okay. Perfect. Thank you very much. So first of all, I really want to thank the organizers for this super inspiring conference, and even more for giving me the chance to share our humble path towards trying to make astronomy a bit more inclusive. This is an effort of a group of people that I will be introducing their contribution through the talk, and it's mostly a talk about our learning process, our mistakes, our very arrogant mistakes, and hopefully lessons learned and doing it better in the future. So first of all, just to set the stage, my research focus on planet formation. So normally I have a couple of slides that are not inclusive to illustrate why we want to study planets. And I say that they are not inclusive because they are mostly videos that we use very often, right, as our tools for outreach, and not only for outreach. And the two videos are, the one well-known, what we are seeing now is the animation of some of the Kepler planets, where we can see the deprojected cartoonish sketch of the different planetary systems found by Kepler, and this is very useful to show the general public how our solar system, one can say that it's kind of an oddity, but also it's very good to also explain that we are not really there in detecting things like our solar system, and it's a problem of detectability, not so much of that they are not there. But it is a very useful cartoon where you can see all the orbits of many different planetary systems and also the size of the planets and a color that has to do with the temperature. And you can show to the general public that we have a very wide range of planetary systems, and that even though we have all these known planetary systems, we know relatively little about how these things form and how the similar stars can form such different planetary systems. And then normally I go with another video where we show an artist's impression, and in a few seconds we start from the collapse of a molecular cloud, and because things are moving, then we know that the collapse won't be just radial, that the material that is falling onto the star will form a disk around it, and through that disk the star will be feeding, and within that disk this process that we don't understand well will happen, where we go from micron-size dust particles to planetesimals of kilometer size and planets, and also reminding everybody that planets form very early on, much earlier on than we thought, before we had the very good angular resolution observations that, for example, ALMA provides. And as I said at the beginning, I use these two videos very often. They convey a lot of information. They are very nice to show, but of course they totally leave out of the picture the blind community or the visually impaired community. And to try to bridge a bit the gap of what we see and what we infer and how we translate most things, and most people, we translate most things in visual images, but that is not really what we study in astronomy. I also tend to use a diagram where we have the wavelength in a horizontal wave that changes in frequency, and different telescopes show the ones that observe, for example, in gamma rays, in the high energies that are towards the left, and the ones that observe in the infrared are towards the right. And what I tend to do is I tend to show an image of the same region on the sky, so basically Orion, because everybody likes Orion, or at least I love Orion. So I show the same region in the sky, how you can see it in high energies, and how in high energies you basically can see some nebulosity, but you cannot really detect the individual stars and say more about the individual stars. If you go to X-rays, then in fact you do not necessarily see so well this nebulosity that we assign to Orion, but we can detect the hotter stars and also the most active stars. If we go towards the visible range, then we can see, in fact, the nebulosity, we will see, we will have a much bigger eye. And that is not where we want to start the planet. Well, I mean, that is where we want to start the planet formation, but definitely not in the visible, because we cannot see, in fact, through these clouds. And I continue showing infrared images where you can pierce through these clouds that are forming stars and planets. And even though we are, all of us human beings are absolutely blind to the infrared, that is where, in fact, we want to look at. And all of this is just to show, I know that I'm preaching to the choir here. I mean, I know that I don't have to convince you of anything, but this is very useful to show people how kind of interesting it is that we translate into the visual all these different images that, in fact, we don't see. They do not correspond to the visual spectrum. So when a few years ago, in fact, 2016, I think it was, I had just come back to Chile. I'm Spanish originally, but I've been living in Chile for quite a while. And talking to Erika Laveda, that gave a really nice talk here, she had started to do as outreach astronomy for the visually impaired. And I've always, I don't know, one of the things that I have liked about my career is that since the very beginning, I've always done a lot of outreach. I think it's our duty, our civic duty as researchers. And I felt so ashamed that I had never thought that with all these videos and these images that I was showing always in my talk, I was absolutely neglecting anybody that had some sort of challenge with vision or in general the blind community. And I thought, arrogant me, okay, I have to solve this. I have to be able to do inclusive astronomy for outreach. How can I be like this? So I got together with a couple of my students, and we were like, okay, we're going to create multisensorial experiences to explain exactly the different processes involving star formation, at least to translate the images that we use all the time into something different, something that can be used with different senses. So that is how our very first 3D model of a protoplanetary disk was born. And what I'm showing here is a picture of our contribution to the Inspiring Stars Joint Exhibition in Vienna 2017. That is just some very, very simple plastic. So we have like a sheet of plastic, circular one with some cotton glue into it, where the cotton is representing the gas, some sand from the beaches of Valparaíso that represents the dust, a star in the middle, and some different structures like rings, like cometary tails of objects that are coming close to the star. And that was our beginning at this journey of trying to make inclusive astronomy for outreach. And of course, there were good things about it. So it's a very low cost material. I mean, we taught several professors how to do it. It's definitely not rocket science. But then we were playing with different materials. We were using also salt because we could smash it to different sizes, and that could help us to explain dust growth and things like that. And of course, someday that we were showing this material, it was raining, and the salt definitely was not a very good idea. But moving forward, derived from the problem that we didn't include the community that we wanted to reach. Basically, we decided to design the thing ourselves. We had a lot of problems in calling those people, calling the blind community to come to our talks, to our exhibitions, because obviously they didn't feel invited. They were not involved in the thing. And when they heard about astronomy in general, at least in Valparaíso, nobody thought that would be for them, because normally astronomy is images and stuff like that. So we learned from that. We enroll in the team. So in the picture that I'm showing right now, we have our first models, these plastic things with cotton, and with one of our awesome partners, Francisco. He's an archaeologist, he's a blind person, and we enroll him, some people from his family, some other people from different associations, and also people, and a specialist in design of products. Then we created a second prototype that allow us to play more with the scales. That was a dynamic piece of Lego, I call it, because it has different pieces and you can pass them and the time is passing and you can see how things evolve. And we tested, prototype with different people with different background and also different levels of impairment in the site. And then we realized the next problem. The next problem was like to explore our model. We have now a 3D printed model that is very easy to print, that we have a lot of information that we made publicly available. But in order to explore planet formation, you need to have an astronomer on your side explaining you. And well, not everybody has an astronomer on the side of the walk, so on the other sidewalk. So what we decided is to create a manual that was self-consistent with the curriculum in the Chilean schools. So it's very biased to the Chilean schools, but the different concepts that are complicated to explain for the teachers, even more for schools where they do integration. We incorporated them, we showed them in the 3D model, and the whole description of the experience and experiments that the students can do is described in a manual that has been designed through the universal design principles, and that it is printed with large fonts and high contrast, but also in Braille, and helps you to navigate this material on your own or with a group of people, but without the need to having an astronomer with you. and hopefully awakening this curiosity that we all have, and that makes us wonder with things like, for example, how planets form. So I will leave it to this. Well, for now, I just want to say that for now, the material is only in Spanish, but we have an army of postdocs that are very happy to translate it in different languages. So very soon we will have it at least in English, in Chinese, and in French. And all of this is available in our webpage. I've put the link there, so it's mpf.cl. And the manual is there, the experiments are there, and the files to 3D print your own disk, and advice on how to 3D print it so that you can waste the least possible material is also there in the webpage for you to enjoy, hopefully.
Great, Amelia, just in time. Perfect. Please include a link in the chat.
Yes.
To a better access. And I don't know if there is any question from the audience. Remember that for the people who sent to us the description of the slides, Santiago is including the description into the chat. So,
excuse me, hello. I have something to ask.
Yes, of course, Madam.
Amelia, how do you plan to show the visually impaired eclipses, the lunar eclipse and the solar eclipse? They are the most spectacular astronomical events that can be seen. So how do you plan to show what a lunar eclipse is and what a solar eclipse is for
Sorry,
I typed it in the chat, okay?
Okay, but I think you were asking about how the blind people interact with the material and how also eclipses can be explained. I think okay. Perfect. Great. So for the material, this disc is basically you can really think about it like a Lego. So it's like a piece onto piece onto piece, and the different textures and the different volumes of the pieces are also conveying information. So, for instance, when the star is very young and at the very early stages, the disc is very fluffy and it's very smooth. So we use different textures also to convey this kind of information. And for the eclipse, in fact, that is great that you asked, because I have a slide about that, how we join efforts with many different people, and thanks to the IAU also, and to Erika that brought the light sound to Chile and Argentina 2019. In 2019, we did, also in 2020, sorry, we did several activities through the whole Chile and also in Argentina. And we had the light sound. I guess most people know, but in case you don't know, so basically this is a very simple, very, very simple computer that what it does is translate the amount of brightness into a tune, in fact, into the intensity and the pitch of a tune. So basically when the eclipse was happening, the tune was lowering in volume and also becoming more grave. And we had it in places where the eclipse was total and in places where the eclipse was partial. And I was one in the places where it was partial. And what we were doing was we were plugging the light sound, to the general speakers that we had, so that everybody will shut up and everybody will just listen. And it was wonderful because people really felt it. We were all feeling the same thing. And it was, as I think we all realized when we try to think about how to convey information in different ways and how to account for the talents and needs of everybody, that we all win. Really, we all get a much richer experience.
Yes, I invite. Sorry, madam. I invite Alison Vierila. I think Alison is connected, to put the link to her poster about the light sound to understand better which kind of device is light sound, and to know that everyone can build the own light sound. It's not so difficult to build at home or at the school. You have another question, Amelia, is by Breezy Ocaña. She said, thanks, Amelia, wonderful work. Did you mention your age target or school grade?
Yeah, that's great. I didn't mention it. Thank you. In fact, the disc has the manual and the disc, the material, has different levels. So basically, we have concepts that are taught from 812 to 818. So I don't know if I can show it decently here. Yeah, here. So here after the index, exactly after the index. Sorry that I don't have a screenshot right here, but we have the concepts with the code that Chilean curriculum use for the grade. So just having that table of equivalence, one can translate it into the different educational systems. But there are concepts from age 12 to 18.
Okay, well, thank you very much, Amelia. Nice job, amazing results also. Thank you very much. Let's go then to the next talk. Will be given by William Saunders. And it's about Astro Soundbites, an audio resource for informal education. So I invite William to take the stage. It's yours. The stage is yours. Your time.
Okay, just getting things set up here.
For a moment, I can see just my face. Okay. Well, now I can see you. Please talk to see your face.
Okay, is everyone seeing the slideshow now?
Yes, very good.
Great. Okay. Hello, everyone. My name is Will Saunders, and I am the co-host of the Astro Soundbites podcast, along with Alex Galliano and Milena Rice. We are all PhD students in astronomy at different universities in the US, and we have been running this podcast for over 2 years. I'm really excited to be presenting here. I've been really enjoying the conference so far, so thank you for having me. Astro Soundbites is a podcast spinoff of the popular astronomy website Astrobites, which for the past 10 years or so has been producing daily high-level summaries of research papers aimed at an undergraduate science level, though it's used by anywhere from amateurs to postdocs and beyond. I find myself reading Astrobites all the time to get an idea on a new field. It has over 50,000 monthly page views and sister sites in many different languages and different formats now. So when we were designing Astro Soundbites to take Astrobites and put it into a podcast form, we really took some time to consider what sort of level would target the right audience. And we realized that sort of on the spectrum of complexity, where you have the most complex being actual papers themselves on the bottom right here, and on the bottom left, say a newspaper article about a topic, the popular science podcasts tend to be somewhere in the middle, but we wanted to be a little bit more complex than that. We realized that by aligning with Astrobites' niche, targeting this higher level, that we would be able to engage our readership and listenership a little bit more. And so that was the idea there. And so we target an audience of undergrads, grads, amateur astronomers, the public who have an interest in astronomy. Over the last year, we've spent a lot of time thinking very strongly about how we can improve diversity, equity, and inclusion using our format. And in order to promote equity, we spent time thinking about how we choose topics for beyond episodes, which I'll explain in a few minutes, but are episodes that go beyond our normal discussion of research, and making sure that we chose research topics that capture the field, which takes me to point number 2, in that we have to make sure we include a diverse representation among our guests and the authors of the papers we feature. And I think participation in the Black and Astro Week in 2020 and 2021 sort of made us realize how intentional we need to be about this. And so it's on the forefront of our mind now. And third, to practice and promote inclusion by doing the things that we can do with our audio that maybe can't be done in the written format with Astrobytes. And that's the way we've sort of moved beyond being just a listener companion to Astrobytes and sort of producing our own standalone content. One of the examples of how we've been doing that is by getting more involved in, I think I may have skipped, I'm sorry, it looks like I skipped this slide, so let me go back. The way our podcast is formatted is to produce an episode every other week between 40 and 50 minutes in length, and we bring research topics together and discuss them. We love to have interviews with as many people as we can. Early career astronomers are our primary focus, but we also include others. And every episode has my favorite segment, the space sound, which we call something a little different every time to give it sort of a fun and cute name. And so that I needed that slide in order to transition to this slide, which is expanding upon these space sounds and exploring sonification more. We've produced sonification for every episode, but in episode 33, we sat down with Gary Foran, who gave a really great talk yesterday, and really started to dive into how sonification can be used in astronomy for more. And I think we settled on these sort of 3 I's, as we call it here: inclusivity, inspiration, and innovation. And I think inclusivity and innovation kind of go more hand in hand. And then to also bring in inspiration for maybe younger audiences, people who don't have as much connection to astronomy. And then I think where Gary did a great job discussing yesterday was how audio can do more than vision can in some cases. And so trying to see how we can be more innovative in that space, or at least promote that, because we realize, I think everyone here does, that sonification is underutilized. And so we took a stab at making our own sonifications using 3 freely available softwares called Astronify, MIDI Time, and Two Tone. And then we sort of invited our listeners to take a stab at it too. And we launched the sonification competition, where we just said, take a stab, make a sonification. Doesn't have to be great, but see what you can produce. And we got a number of submissions. They were a real joy to listen to. And then we crowned a winner and runner-up for the competition. So we felt that was a really great way to interact with our listener base in a way we haven't before, something we really want to improve upon. So here I have just some examples of space sounds we've featured before, just to give a little bit of an idea of the breadth. And these are, of course, made available through different collaborations, but can someone confirm that you're hearing the audio? Was the audio going through there? I'm not hearing anything. Yes, okay, thank you. So that's a great example of sort of a very classic sonification, scanning across an image to show, I'll play it again, just a quick, oh no, it's playing the next one. A quick segment of a star cluster sonification in multiple wavelengths. This is sort of very standard and something we might play on the show to connect to the theme and then discuss different ways that the creator of that sonification might have chosen certain aspects of it. The second one is one of my favorites. Take a listen to that. So what I really love about the sonification is it connects the phenomenon of a heartbeat star in astronomy, where you have a close binary with a highly elliptical orbit, to the sound of a human heartbeat. And so that really hits that inspiration node really well, where you can get someone, intrigued in a concept where maybe, in fact, the visual component doesn't work as well, and this really draws someone in. And then last, I'll play the sonification that I produced for the episode, which I have to admit is not very good, but was certainly better than nothing. so my goal with this sonification was not as much to make a pretty sound, but more to convey information that this was in fact an observation of a stellar occultation that indicated atmospheric waves in the atmosphere of Mars. And you can hear it in a way that's actually even easier than seeing this data represented. So again, it was my first attempt to do sonification, but demonstrating to the listeners that it's not that hard to get started, and it really opens up other avenues for communication. Let's see, it's playing again. All right, moving on. So that was just one example of the type of Beyond episodes that we produce. And Beyond episodes are the same style as Astrobytes Beyond posts, where we want to cover topics like academia, DEI initiatives, lifestyle, things like that, strengthen the network of early career scientists and bring in a lot of stories. And I think that's really an important message, is that give people an avenue for storytelling. So here are examples of some of the Beyond episodes we've done, and some of the ones I enjoyed the most. Episode 35, we brought in 3 people who ended up in astronomy PhDs by unconventional paths. It was great to hear about their different experiences. And then in episode 43, we heard from 2 science communication veterans on how to be better communicators, including how to get started, how to find jobs in science communication, and then how to do more inclusive science communication as well. We're really grateful to have had about 10,000 total downloads so far in about 2 years that we've been going. That averages about 110 in the first week after an episode comes out, which gets up to 150 in the first month, and then continues to rise above 200. On the bottom here, I'm showing a plot of the downloads per episode in the first week, first month, and all time. And so if you can see the trend here in the first week and the first month has been gradually increasing. We have a very rock solid listener base, so that's really great. And then we've been adding more people as we go. But also interestingly, we've had some bumps and then some dips and bumps and dips. And I think that relates to the fact that we've been attending conferences. And so that's each bump corresponds with a new conference attendance. So I'm hoping we get another bump after this conference as well. Going forward, we want to continue our initiatives to promote underrepresented groups and continue to do more with sonification and with interviews, which continue to be the highlight of every show when we have one. In addition, we want to increase our reach to international audiences. So you can see here on the right, about 62% of our audience is from the US. So it's definitely a majority, but not overwhelming majority, which is good. But we want to continue to grow the international audience and pick beyond topics that have a broad appeal, attend conferences and in person as it becomes safe to do so, and then find new and creative ways to promote the show. We're very grateful for the funding we've received. We don't need a ton of funding, but the little bit here and there we get enables us to keep going and producing our podcast. If you want to listen, the best place to find us is on our own website, astrosoundbites.com, but you can listen on Apple Podcasts, Spotify, Google Podcasts, and SoundCloud. Those tend to be the most common, but in fact, just about any podcasting app you might use probably has us because it will grab the RSS feed. We're grateful for all the people who lended a hand or came on the show to help us make this possible. A lot of people from Astrobytes help us getting started, and a lot of people coming on for interviews. And that is where I will leave things for today. Thank you very much.
Great. Very nice talk, really. I know the Astrobytes and Astro Soundbites, so it's an amazing tool and resource. So congratulations. I don't know if we have any question in the chat, but great talk. And I don't know if someone wants to make any comment, or we have some raised hand. For a moment, no. So, well, I invite all of you to revise, to be part of Astro Soundbites and Astrobytes, and to increase? Oh, well, yes, here is a question by Hugo Alberto Jasso. It's about the translation to panic. Do you have translation to panic? What is that, Hugo? Spanish. Hugo?
Oh,
anyway.
Asking if we're translating. No, at this moment, no, we're not translating into any languages. I think translating a podcast, I'm not sure would be the best way to do it. I think you would want to have a separate Spanish language podcast that would have its own hosts and produce similar but unique content. I think if anyone's interested in starting that podcast, I'd be a big supporter.
Okay, yes. Remember that we all the time are pushing, trying to have the resources in more languages, because part of the inclusiveness is to permit to understand very well the contents of the resources and the material. So, well, have you done interviews with people outside the USA? Is asking by Chiamiso Macuela.
Yes, we have. Sometimes it's students in the US who are from other countries, or people who are working, who are actually US who left and are working in other countries or otherwise. I don't remember off the top of my head who they are, but we've definitely had some, not many. I'd like to increase that number. And I think a great way that we use to find people to interview is by attending conferences. So, for example, I'm going to the American Geophysical Union conference coming up in a few weeks, and I hope to interact with a lot of people there so I can meet people of different backgrounds. Yeah, thanks for that question.
The last question is by Gary Hemming. It's about if you have found that your audience has changed because the pandemic. Did you pick up people who were in lockdown, who maybe before wouldn't have had the time to listen?
Yeah, it's a really interesting question. I think all of the podcasts saw a huge decrease in listeners when the pandemic just started, because nobody was commuting. And that's when most people listened to podcasts. But then things picked back up. So people found a way to put podcasts back into their life. I did the same thing. I stopped listening for a while and then started listening again when I was going on walks or doing other things. So I think our listeners have continued to grow. We find that they listen to the whole episode most of the time, and they're engaging with us, sending emails and suggestions. So I think we have a really great, devoted core listener base.
Okay, thank you. Thank you very much, Will.
Thank you.
We invite Tomás Madura, who is the next speaker. And the topic of the talk is astronomy for students and with visual impairments, development of the career exploration lab. Tomás, your time.
Great, thank you very much. So I want to apologize off the start. There are some landscapers doing some leaf blowing right outside my office, so there may be a little bit of background noise, but hopefully it's not too bad. And I would also like to thank the organizers for allowing me the opportunity to present my work and the work of my team. I'll talk about my team as I go through the talk, but there are a lot of people who have made this work possible, and it would not be possible without the contributions of everyone involved and of the blind and visually impaired community. So I think we're all familiar with the problem, which is that nearly everything we know about the universe comes from studying light and performing computer simulations, and most astronomy data consist of two-dimensional images or spectra. And we can ask ourselves the question, obviously, can we do better than pretty pictures? And can we teach the wonders of the universe to those with visual impairments? And as we've seen from a number of talks at this conference, the answers to this question are yes, but how? And we've already seen some amazing techniques with data sonification and tactile models. And so I'm going to focus a lot on the tactile side, and specifically using 3D printing to help teach the wonders of the universe to those with visual impairments. I would like to also briefly mention that This work is being funded by a very generous Innovative Technology Experiences for Students and Teachers grant from the National Science Foundation. And so this is going to be a multi-year project. We've done our pilot studies already, and I'll talk about the results of those. But this is going to be a multi-year division of research on learning study where we're actually going to study the effectiveness of the curricula and models that we are developing. So this is our team. It consists of myself. I am a professor of physics and astronomy at San Jose State University in Northern California in the San Francisco Bay Area. We also have Dr. Carol Christian, who is the Hubble Space Telescope Outreach Project Scientist at the Space Telescope Science Institute. Dr. David Hurd, who is a professor of geosciences at Edinburgh University of Pennsylvania. He is one of the main co-authors of the Braille books that NASA has developed. NASA has a number of Braille and tactile books, and David is one of the main co-authors on all of those books. And then we also have Dr. Tiffany Wild, who is a professor of teaching and learning at The Ohio State University, who specializes in research on STEM education for students with blindness and visual impairments. And last but not least is our inspiration for the project, Mr. Kenneth Silverman. Ken is an engineer and patent attorney who works in the Office of Education at NASA Goddard Space Flight Center, but Ken is completely blind. But that doesn't stop him. He is an amazing guy. He does rock climbing. He does engineering. Like I said, he's a patent attorney, and he's just a fantastic and wonderful guy who's been contributing to our project. And he's tested all of our models and all of our curricula as well. So what is this STEM Career Exploration Week? So this is something we've pilot tested first at the South Carolina Commission for the Blind in 2017 and in 2018. These are week-long summer camps for the students. We use 3D printing technologies to help high school students with visual impairments explore STEM careers using tactile astronomy models, and we introduce the students to professional role models who are blind but who have successful STEM careers. So what we're actually doing is the goal of the project is to motivate students with visual impairments to become interested in science, technology, engineering, and mathematics, so-called STEM fields. But we're using astronomy as the hook to get them interested in STEM. And the idea is to motivate these students to go to college and then to eventually become STEM professionals themselves. So here on this slide, I have a couple of pictures of some of the groups of students that we've worked with, but with their identities blocked out. Usually during these camps, we have 10 to 15 students who are blind or visually impaired participate in the week-long camps. They range in age from about 15 to 20. They represent all areas of their home state. They're identified by what are called their transitional vocational rehabilitation counselors as having aptitudes and interests in science careers. The students stay in a dormitory on site for the entire week, and they participate half in the classroom and astronomy activities and half in social and recreational activities. So it's not just a chance to come and learn STEM and to learn astronomy, but it's a chance to bond with each other and to interact with like-minded peers. We do pre- and post-evaluation data gathering in order to measure our program effectiveness and to assess the quality of our educational activities. I want to highlight one of the other things that we do, which is illustrated in the photo that's in the bottom right, which is one of the things that we also do is we take the students to local STEM businesses or local STEM facilities in order to introduce them to possible STEM career paths. And one of the places that we actually went was in South Carolina. They have the
recording in progress.
They have the factory where the 787 Dreamliner aircraft is built by Boeing. And so we were actually able to go to the factory where the 787 Dreamliner is built, and we had the students take a tour of the factory and learn about possible STEM careers. And Boeing actually does hire individuals with visual impairments to do a number of different STEM careers. So on this slide, I just wanted to give a global representation of a lot of the different types of models that we have. So the slide, for those who can't see it, the slide is showing images and pictures of a lot of the different models and activities that the students participate in. So it's a collection of models, and we teach astronomy concepts ranging from constellations in 3D to galaxies, to stars and stellar structure, to star clusters, to the Hertzsprung-Russell diagram, to galaxies, to large-scale structure in the universe, and also the cosmic microwave background radiation. On the top middle, there are a couple of images showing students exploring 3D printers. So we also teach the students about 3D printers and how 3D printers work. And we also teach them how to use 3D printers. And we try to make everything as accessible as we possibly can. Although, to be brutally honest, 3D printers are still fairly inaccessible to the visually impaired community. And so there's still a lot of work that needs to be done. On this slide, we just have a couple of more images of some of our models. On the top is a 3D printed model of the constellation Orion that students can explore from different directions and different angles. The size of the stars represents the brightness of the star. The color represents the temperature. And then you can't see it because the images aren't high enough resolution, but there are tactile features on the spheres that represent the stars to also indicate temperature for those students who can't see the colors. And then we also have some other images of galaxies that have been developed by Carol Christian at Space Telescope Science Institute. These are real galaxies. These 3D tactile models of galaxies are based on real data from the Hubble Space Telescope and other instruments, with special tactile features to represent things like star clusters, dust, gas, the central supermassive black hole, all of that. So again, these are just some representative images showing students exploring the models and giving an idea of what some of the models look like. Like I said, we also introduce students to role models who are blind, who have successful STEM careers. So Ken, the IAU's close friend Wanda Diaz-Merced, some other professional STEM and astronomy people who are visually impaired have come and talked to the students about their experiences being someone who's visually impaired doing STEM or doing science or doing astronomy. And they kind of act like role models and help convince the students that they themselves can also be successful in STEM. And then we introduce the students to other areas of STEM that they could potentially pursue besides astronomy. So these include physics, engineering, biology, chemistry, geoscience, computer science, science education, and then 3D printing. We've also done camps with the Michigan Bureau of Services for Blind Persons in 2018. We've had a couple of these STEM career exploration weeks in 2018 and 2019. We also had some very nice press releases through the state of Michigan to advertise our programs and to help advertise the work that we've been doing. But one of the things that I'm really excited about that we did is a special program where we actually had students build 3D printers themselves. So 3D printers have become extremely inexpensive, relatively speaking. You can get 3D printers now for about a good quality 3D printer for about $170, and it comes as a kit. And what we did is we had the students with visual impairments actually build the 3D printers themselves and learn how to use the 3D printers. And as far as we know, this is the first time anything like this has been done, where the students themselves build their own 3D printer, learn how to use it, and build their own models. So I have a really short video here. You may hear some background sounds, but this is just a video of the 3D printers building their first 3D print models. And these were the 3D printers that were built by the students during our 3D printer build camp. So the students had an amazing time. They loved the camp. And the other thing is we allow the students to take the 3D printers home with them. So the students get to keep the 3D printer, and they get to use the 3D printer for their own activities and for their own resources. One other thing to quickly mention is that we do educator partner institutes. So it's important to have STEM teachers and teachers of the visually impaired involved. So we recently did a professional development workshop, a weekend-long professional development workshop with teachers at the Maryland School for the Blind. And so we also have teachers testing out all of our models and all of our activities and giving us pointers. And so this is really a kind of a feedback-driven process between both the students and the teachers who are teaching the students. And we've received an enormous amount of very positive feedback and also some tips and tricks on things to improve. And so we're in the process of doing that now. We're also doing data collection on the effectiveness of all of our activities and all of our models, but I'll skip that. I'll keep this on for just a few seconds. Hopefully the slides will be made available. But what we're going to do is we're going to make all of our models and lesson plans freely available to everyone. And these are just some links that are for access to the models. So then the next steps, work with teachers and students to refine our models. We plan to extend to more Council of School for the Blind schools. We're going to do about 13 states over the next 2 to 3 years. And then we're going to share what we learn, and we're going to share all of our models and lesson plans and activities with the community as soon as everything is done and refined. So I'm out of time. That's the end of my talk, and thank you very much for listening.
Thank you very much, Thomas. I would like to remember that you were online during our first workshop on astronomy for inclusion in Cartagena de Indias, and now you are online again.
Yes, yes.
The next one to be face to face, I hope.
Yes.
Yeah, well, you were a precursor. You were an amazing guy there. Thank you. We have questions and comments on the chat. And Annie's asking about how to contact you regarding your work and how do I do that. But if you want to make to expand the connection, please do it.
So I'm putting my email address in the chat. It's just thomas.madura@sjsu.edu. And you're welcome to, that was not to everyone, that was just to the organizers. Let me copy and paste it and send it again. And you're welcome to email me at any time. And I'd be happy to share what we've learned and to collaborate.
Perfect. Iliana, would you like to make by yourself the question? Because you said I have a question. If you want, open your mic and ask the question. Iliana, are you there? Iliana, Andrew Chop? What? I don't. The host do not. So write the question. I will try to read.
Yes, I unmute. Sorry.
Go on.
Okay. Thank you so much for the talk, Thomas. It was really interesting. I have a question because I do not know much about the issue that you are working on, but I understand, maybe I'm wrong, that there is a problem with the projection with the blind people. Since the blind people or the people that do not see very well do not finally understand the notion of the projection. And in astronomy, the projection is an important issue.
Yes, I think that's right. I think they have a very difficult, as far as I understand, and maybe Noreen Grice or someone else can actually elaborate on this further later today. But as far as I know, I think there are some issues with understanding projection and projection effects, especially projecting three-dimensional objects into the sky plane.
Yes, because we are working with three-dimensional stuff. and it's different to touch the thing and to see projection in the sky.
Yeah, so one of the things that we actually do is we actually present both perspectives to the students when we do our activities. And so we want the students to understand the 2D projection. So we usually have 2-dimensional or 2.5, it's called 2.5D raised tactile images. And then we have the 3D models as well. And we're trying to help the students to navigate and understand the differences between the 2-dimensional version and the 3-dimensional version. The other reason this is important is because when students do standardized testing, they don't have access to 3-dimensional models when they do standardized testing. They are provided with 2-dimensional images and graphics. And so it's very important for the students to learn how to interpret these 2-dimensional images and graphics so that they can actually perform well on tests and standardized tests.
Thank you so much.
Okay, thank you. Thank you, Thomas, again. Nice work.
Thank you very much.
Let's go to the next speaker, who is María José Villarreal Gómez. He will give a talk entitled Astroparamo-Science Club of Planetary Habitability and Climate Change. I don't know. Speak in English or in Spanish?
The talk is in English.
Perfect, great. Well, now is your time.
Okay. Please let me know if you can see my screen.
Yes, we can.
Okay. Thank you so much for your kind introduction. Hi, everyone. My name is María José. I'm a student at the Universidad Industrial de Santander in Colombia, and a member of HALEY, an astronomy group, within the framework of this Congress on Accessibility and Inclusion in Astronomy. I have the pleasure of presenting you the Astroparamo educational project. So to get started, we all know about climate change. It is a fact with scientific evidence, and every day we have less time to solve it. Consequently, we have begun to wonder if it is possible to inhabit other worlds, or how we could identify another planet similar to ours, and if it is possible to migrate to another planet in case ours is not available. Until now, we know that the trip to other planets is not easy. So from the HALEY group, we started to wonder if we could use the teaching of astronomy as a bridge to raise our conscience about climate change. And from this question begins this educational project. For the beginnings of Astroparamo, we have had the support and inspiration of several institutions, which are the ones that you can see below. And to begin with the construction of this project, we used as a guide the Klimawandel project manual by its German name, Klimawandel. It is an educational project that, through guides and simple experiments, seeks to teach and raise awareness about climate change in young people, especially in the school, and also relying on the teaching of astronomy, especially astrobiology. With the permission of one of its creators, Cecilia Escorza, we translated the manual into Spanish and adapted into kits with all the didactic materials and guides in it. Another project involved is the Racimo project, which is a citizen science project that focuses on school children to actively participate in the collection and analysis of environmental data using weather stations. And from HALEY, we integrate these two projects into one, that is Astroparamo. With the project foundations, we wanted to focus it initially on the rural population of our country, Colombia, which represents around 20% of the total population in our country. And these areas doesn't have the same opportunities that a person in city have. So we want to take education to them. And this with the support of the adapted kits, which contain all the guides and materials to carry out and understand all the experiments and the theory behind them. Now we are in the process of adapting a website where the people can find all the necessary information to perform these experiments related to climate change and astronomy. And we are trying to adapt the materials with materials that you can actually easily find at home and thus reach more interested people or even schools. And similarly, Clima Wonder has its English website and also in Spanish. If you want to take a look, here's the link. So for our first version, 3 municipalities in the Department of Santander participate, which are Berlin, Betas, and Surata. These are small towns, are far from large cities, they have limited internet access, and are surrounded by the Páramo of Santurban, a unique and charming ecosystem. I want to share to you a little of the social and economic information of the participants. We started with 29 students between the ages of 13 and 16. The ratio of men and women was quite similar. Most of them lived near to the school. However, 14% take more than an hour to get to school, even by a car. And that was a big restriction to their education. Also, computer access was always limited. Not everyone had a computer at home. Internet access was also not optimal. Mostly it was limited or acceptable. Even on rainy days, we lost total connection with them because they didn't even have a mobile signal, so we can call them. It was impossible. The principal source of connection was Wi-Fi or mobile data. And in the last graph, you can see that most of them only had 1 or 2 devices where the whole family could connect to internet. And that was also a restriction because they have to share that device with their brothers, with their parents, they have to study. And only 22% had their own device. And after this version, we ended up just with 17 students because some of them didn't have much time to be part or had to work to help out at home, so they preferred to retire. Based on these conditions, we designed 4 kits. The student received one of the kits, which is self-contained. It has all the instruments. Here are the kits. It has all the instruments, all the material didactic, all the guides that they need to understand the different theory and the different scientific challenge that they were into the kit. And to follow up the activities and answer the questions and any concerns that they might have, we create with each municipality a WhatsApp group because, for example, Zoom meetings wasn't able for them, or by Skype or another meeting like Meets, it wasn't able for them because of its internet connection. So we had to create WhatsApp groups. And once a week, they could share their experience, their questions with a tutor from our group, Halle. And the tutor helped them to go through this scientific challenge and help them to perform the experiments. And sometimes we made calls if one of the kids didn't report during the week because sometimes they are very busy at home. We also had a 5th module with a climatic station called EVA, here is, which measures the variables of temperature, humidity, precipitation, irradiance, and pressure. Only 1 student per municipality had this station. It was provided by Make Sense and Enterprise, a company, sorry. And this station had a Python tool called Benice that allows you to visualize how each of these variables measured by the EVA station changed. It's very important to know these changes because these are agricultural areas and where the variability in the climate affects the final products of the harvest. So it's important for them to predict times of frost, and this station can help them keep a track of climate change, so we can take care of their harvest. And Benicia was, as I told you, was installed just in one computer per municipality. A week ago, we met some of the students because of the pandemic. We wasn't able to visit them. So we met students from each municipality. It was a day of socializing with the science club, sharing experience, sharing questions, sharing talks, all they want to tell us. The project was well received by the students and teachers who participate, and they want to continue the next year. In the center, you can see a small collage with some of the experience they carry out, and these were like their favorite. As we carried our telescope and did a solar observation with them, because they haven't seen, some of them haven't seen a telescope in their lives. So we try to teach them how to use it and let them observe it. And here you can see the picture of Nicole. This is one of our students, and this one was the girl who had the station Eva at her home. To conclude, these projects are essential since they offer rural students the opportunity to connect with science, with the university, which is often a limited option for them, and they have to stay at their municipalities working in agriculture, and some of them have big dreams. They want to become, for example, physics or astronauts, and also allows them to discover and develop probably unknown talents, and then in the future participate in STEM communities like we are doing right now. And they make it possible to reduce the social gap between urban and rural areas in the country and offer development strategies at a personal and professional level. And as a part of the team, we hope Astroparamo continues next year, increasing the number of people involved and in the team in order to reach out more Colombian areas. And that was the presentation of Astroparamo. Thank you so much. If you have any question, please let me know. These are the contact information. You can write us any question or suggestion or anything you want to. Thank you.
Thank you. Thank you very much. Muchas gracias, María José. And well, it's time to questions. Let's give some minutes to the people. It's amazing to see your statistics about the connection of the people, because a few years ago, probably the cafe internet will be one of the options, and now you have no one at the cafe. All is at home or at the mobile, right?
Right.
It's an amazing thing, because changed a lot the profile of the access to the internet, I think.
Yes, now they have something they call Punto Digital. It's like a station from the government that gives internet to all the municipality. So internet cafes are not necessary anymore, because all the municipality have their own Punto Digital. But those points doesn't work too well sometimes, and they are just completely off internet.
There is more connections at home also.
By their cell phones, for example, or their parents' cell phones.
Yes, okay. And what about the pandemics? Is the same? This project is part of the pandemic's problem, or is a general project for all the time?
We made it during the pandemic. And for example, the WhatsApp meetings were because of the pandemic, because we wanted to go there and at least once in the month, visit them and talk to them, but because of the pandemic, it was impossible. So the teachers, for example, help us to solve their questions, but in the next year, we hope to make it more present. Yeah. and help them with their questions and try to make it bigger. Because as you see, we lost some students during the process.
Okay, well, nice. Thank you very much for your presentation. And let's move to the next speaker. Thank you, Maria Jose. Thank you. I think it's one more question. Yes, it's from Anaeli Pacheco Blanco. Did you also hear the knowledge these communities have to share?
Yes, the next year we're trying to make Astroparamo more specific for every community necessity. For example, Berlin is agricultural area. They have onion and potatoes, so they are always worried about frost, and they are trying to predict those frosts in order to avoid to lose their harvest. So that's what we are going to try to do, to focus on their special
needs of
problems.
Yes, of problems. Great. Well, congratulations. Thank you very much.
Thank you to you.
Next speaker is, we have the second invited talk for the afternoon, and my afternoon at least, is the speaker will be María del Carmen Argudo Fernández. Is an astronomer from the Pontificia Universidad Católica de Valparaíso, and a PhD from the Institute of Astrophysics of Andalusia and University of Granada, Spain. And she's working mainly in galaxy formation and evolution, but also she leads the project Astro BBI, Astronomy Educational Kit for the Visually Impaired Community in Central and South America. And we have the pleasure to receive her here in our Zoom room. So María del Carmen, if you are there, your talk is Astronomy Inclusive, inclusive astronomy, Astronomía Inclusiva in Spanish. And now is your time for the talk. Welcome.
Thank you, Beatriz. Thank you for the very nice introduction. The honor is mine, really. I'm gonna share my screen.
Yes, I can see you.
And also with some sound, because I have a video, I think.
Great.
Oops. I sent, or maybe I didn't submit. No, I didn't submit yet. The slides on my presentation, because there are some links, so people can visit later if they want to look for more information.
Okay.
Yeah, so I'm gonna start presenting. Yes. Okay, so I'm María Argudo Fernández, and I'm giving this talk called Astronomía Inclusiva, which is inclusive astronomy in Spanish, and I'm going to talk about this group. I think it's the best group ever, so I'm here just on behalf of this incredible group of people. So this is me. Seeing he and her are my pronouns. I'm an astrophysicist. I'm working right now as an associate professor at Pontificia Universidad Católica of Valparaíso in Chile. I'm the PI of the Astro BBI project, and I will talk a little bit about this. I'm also a member of the C1 Commission for Astronomy and Education, Astronomy Education and Development, Commission of the International Astronomical Union. I'm the current president of the Chilean Astronomical Society, SOCIAS. So then I'm going to start with this image that we use in our SOCIAS talk. I'm going to describe this. This is a picture of the north of Chile taken from the International Space Station. I think that there is something here. Ah, yes. Yes, Erika. Okay. So what what you see from this for this image I'm going to describe is that you see the north of Chile, and you see that for one side, you see that there is the Pacific Ocean, and at the other side, you see the Andean Mountains. What called the attention from this picture is that from the ocean and from the mountains, there are clouds. But here in the north of Chile, there are no clouds. So this is because a phenomenon that is given in this place, that is the Humboldt current. And they allow that in this area, that is the Atacama Desert, that is in a very altitude place, the condition of the atmospheric condition is that a lot of cold and dry. So this means that it's a very stable atmosphere for professional astronomical observation. So that's natural then to consider Chile as the astronomy capital of the world, as a natural lab and a place for astronomy. In fact, we saw this number very often. I'm not, so nothing, okay, now, that by 2030, if we consider the aperture of all the telescopes in optical and infrared larger than 4 meters in diameter, the collector, the worldwide observational collector of this telescope, 70% of these capabilities will be located in this area in the north of Chile. Now I'm going to give another numbers. According to the last census in Chile in 2015, when they incorporated some kind of criteria to evaluate the number of people with disability, right now in Chile there are 18 million people. 60.7% present some kind of impairment. So this is about 2.8 million people. Of them, 19 are vision impaired and 9% are hearing impaired. However, this number will be a bit underestimated because according to the International Agency of the Prevention of Blindness, there is 4 million people that are visually impaired in the south of Latin America. This is considering not only Chile, but also Argentina and Uruguay. So we astronomers that are working in the best place in the world to do astronomy, we want to everyone, not only in the world, but also in Chile, independently of their abilities, can have this, enjoy the skies somehow. So this is how, in some years ago, some astronomers located and distributed in different institutions in Chile, we joined together to bring astronomy to everyone, to remove the existing barriers for everyone. So our goals are encompassing in these three sustainable development goals. The number 4, quality education, number 5, gender equality, and number 10, reduced inequalities. Our idea was, if we can do astronomy, that is a science that is so visual intensive, to be available for everyone, and everyone can enjoy and learn, then we can do it with any science. So then this is a picture that you have already seen, that Amelia saw before. Sorry, Amelia, I didn't know that you were so embarrassed by your version, first version of your immersing kit. So I'm showing here, I'm going to describe a little bit. There is a main central picture which shows like a stand with different accessible material for astronomy. There are some 3D printed models. There is the first version of the kit to understand planetary formation. There is also the first draft of the Astro BBI kit, which are 3D printed images of galaxies. We call them tactile images of galaxies. I will talk about this a little bit later. And also there are some tactile material, including kind of tactile electromagnetic spectrum to understand the differences in the tactile, how you see, how you feel that the wavelength, it's larger or shorter, and also some maps on how our galaxy looks like. Sorry, that's my dog. How the galaxy looks like by the touch at different wavelengths as well. Also, you can maybe distinguish there is a model of the solar system in a scale of distances and sizes where this yoga ball or Pilates ball is the sun. I think that maybe many of you are familiar with this kind of models. So here, and the lower part, there is a picture of our representatives of this exhibition. This was the Inspiring Stars exhibition that started in the last general, well, in present mode general assembly of the IAU. There are another two pictures with some people. It looks like there are people with some kind of impairments that are interacting with this material. We are also connected not only to try to adapt the astronomical concept to people with impairments, but also we keep connected with the recent events. For example, here in this new slide, I'm showing in the central part the famous picture of a black hole, the picture that was taken by the Horizon Events Telescope of the supermassive black hole in M87 galaxy. So this picture was in all the media, in television, it was in social media, and also there were some memes of them. So we also want to bring this to blind people. So here is in the left, yes, there is a picture of one member of our team. She is one of the members of the Oscopio. They are going to talk later, so you are going to know them as well. With an adaptation of these images, and there is a blind kid that is touching this. Also, this kind of materials, we have learned that we need an astronomer behind this, explaining what is happening. Also, this picture or this adaptation is not telling anything if you don't explain how an AGN works, how a black hole works, how the accretion disk around a black hole works. So there are also some material made with low-cost material that you can find very easily and reproduce. So you see there is some people sit in different chairs, and each one have these kind of models. So this is one of the Oscopio session when they work and do very large sessions and accompaniment with people to try that they understand all these themes, and then they can understand what they are touching. In this lower picture, I'm showing also another stand and also some representative of this team as well. And in this case, we were presented in the Latin American meeting of the IAU in 2019, that it was here in Chile, in the city of Antofagasta. In this occasion, we interact with the scientific community, also to raise some aware and connection with the community to see what we are doing. Maybe they can come with some ideas, or maybe we did some activities with them where they have to interact with this material, and they also provide feedback. So not only with people with disability, but also with the scientific collaboration on the scientific community. Well, my part in this first efforts on bringing astronomy to a more inclusive public was with this activity, the Astro BBI project. We created a kit for an educational kit for astronomy focused on a community with visual impairment, so to the blind and visually impaired community, in particular with students. This project was funded by the Office of Astronomy for Development in 2018, I think. Yeah. We carry out this project during 2019. I think that some people here in the meeting have received a kit. They are part of the Astro BVI teachers community. I really recommend people, if you have an idea, to put it in a proposal, as in a proposal for this annual call. I started this idea with a very small scale project in collaboration, and thank you very much to the Tactile Universe that provide a lot of material that we adapt from English to Spanish and Portuguese speaking countries. So we started, my idea started with something small scale, only in the city in Chile. And then the first conversation saying, no, if you really want to have an impact, you have to do this at a country level. Then we presented this proposal, and they, in the first round, they provide you comments to enhance your proposal. And they say, oh, we know some people that maybe might be interested in your kit, in your idea, because they have done similar things. And then they put in contact with a lot of amazing people with a lot of ideas and very helpful, that also helped me a lot to carry out this project. People in the planetary of Medellin in Colombia, with Amelia with the Touch of the Universe from Spain, and many other people in many Latin American countries as well. And then we started something like South America, and then we had to move to Latin America because also people in Mexico was interested, and why not Iberoamerica, because we also sent some kits to Spain. So here is a link to our webpage. All the material is available. We not only create the kit, but this is like, it has also a guide to guide the teachers. So we focus on providing training to the teachers. We also developed some online workshop with them. And also we have some activities that they can develop in the classroom, starting from many very, very simple terms in astronomy, like trying to help them to explain what it's the apparent size of the object, if they are big but they are very far. So to try to explain perspective, that is something that is very easy for us, the people that can see, to understand this, but it's super difficult for a blind person, and even more for children. So we prepare as a guide 2 different activities, and the last part, the most advanced part of these activities is the introduction of galaxies. You don't start telling children about the astronomy on galaxies. You start with the stars, with the planets, and then we wanted to move for a more complex concept as galaxies. We are also very grateful that we highlight all the impact that we get during the implementation of this project in the first year in a special edition of Astronomy for Development in the Communication for Astronomy to the Public journal. I think that last year, or a couple of years ago, with pandemic, I'm losing track of the years on past years. I'm sorry. Maybe many of you have the same problem as me. Well, here, this is a special slide for an event that was a super massive, and I also will say was a breakout point for this community, for this Astronomia Inclusiva or Astronomy for All group of people. That was the total solar eclipse in Chile. So Chile is a very large country. To have an idea, we have 40 different degrees on latitude from north to south. So we also see different skies if you look at the sky in the night in the north of Chile or in the south. And so it's not very surprising if I say that we have 3 total solar eclipses in 3 consecutive years. The first one was in 2019. And this total solar eclipse is an event that called attention for many people. All people are looking at the news about this total solar eclipse to know if they are going to have activities, etc. So we bring the eclipse to try to do inclusive activities for everyone. We give special thanks for the people that providing us these nice books, tactile books to explain the eclipse in 2019, the 2020, and the 2021. I think that also that it's included, I don't remember well. Of course, the system sounds. And well, there are different pictures here from people in different locations in Chile where these activities were carried out. I call this a break point because it's when we started this Astronomy Inclusiva group, and then Erika started to bring together in a WhatsApp group. So we are a WhatsApp group of more than 100 inclusion enthusiasts, not only astronomers, but it's a very multidisciplinary group with students, anthropologists, computer scientists, science communicators, archaeologists, teachers, artists, and of course, people with disabilities, and also people from very different countries. This is the group Astronomy Inclusiva, and I want to call the attention for our logo. We maybe don't have a web page. We are a WhatsApp group, but we have presence in social media, and we have a logo. This logo tries to represent this group. So you see the logo is a hand that is taking a ball. This ball could be any astronomical object, can be a black hole, can be a star, which can be any compact astronomical object with a disk. We know that disks are present in many astronomical objects as well. And the hand has different colors. Each finger is a different colors, and that represents the diversity of this group. We are a lot of institutions working together in this group. For sure, there are many others that we are missing in this picture, maybe others that have come later, and maybe we need a better picture to show this. So I'm going to summarize some learning that we gained in the last years since this project or this group started. The first is diversity. It is the best that is happening in this group. We know that people with different ways of facing challenges can bring creativity and new tools to achieve better solutions. We also have learned, and also we saw yesterday in one of the key talks of this workshop, that equality is not the same as equity. In fact, equality is much better than equity. We also have learned that inclusion is better than integration. We also have learned the importance of the co-creation. This is a phrase that you have seen in many of the talks during this workshop. There's nothing about us without us. No? Sometimes it can it happen that maybe you have an idea, you want to what happened, just the example with Amelia was, this is so before, you have an idea on how to adapt material, but maybe it's not a good idea. Maybe you are not in the right direction, and that's okay. You can just start from scratch, and that's okay. And also you can co-create something new, incorporating innovation and giving a place for creativity, and also find new ways to communicate. Another thing that I like, I think this is one of the best things of this group, is the collaboration. We don't compete each other at all. we share material, we share experiences, we share all the knowledge, and of course the motivation, because you need motivation. Sometimes creating new material or all the work that is implied behind all those activities, you need motivation to do it. Sometimes maybe you are tired and you need motivation. So we also share motivation. We try to not reinvent the wheel. So it's better to collaborate than working by in separate. And also in that way, we can maximize the impact of these activities, because after all, the goals that we have are all the same. Well, I would like also to use some minutes. I don't know, I forgot to put my chronometer to look at the time.
You have 8 minutes.
Then it's okay. Thank you. There is another project that this has the backup of the Chilean Astronomical Society that is called Breaking the Barriers. In this case, the big aim of this project is to normalize the inclusion, in this case Chilean, sign language in the professional astronomy activities. So I'm going to, well, I added this a link. I'm going to just visit a little bit the webpage, because another breakpoint is the pandemic. And we have to move all the activities to virtual activities. And without the support of this project, it would be impossible to do all the things that the Astronomía Inclusiva project has done. We are working with a foundation, interpreters, a foundation for all the interpreters of sign language in Chile, and we have carried out well. There is many different nature of activities. You have seen Erika was speaking about some of them yesterday. I don't know if they Telescopio, maybe they are going to show more of them. For example, this is an image of in real-time astronomical observation, and you see here the interpreter. Some activities, in massive activities online, maybe in more, not in a very outreach focus, but more on Chilean, I don't know, patrimonio, historic buildings or history. They also requested to SOCIAS through this project to have an interpreter. There is storytelling with interpreters, the Astory Day, you see also the interpreter, and many other talks and activities. Here you don't see the interpreter, but you see that the sign that says that is going to be an interpreter. So now this is normal. Actually, now if there is any event online that is going to happen, then the people that used to see this, our audience say, where is the interpreter? Why this hasn't have an interpreter? So we are reaching our goal, is that to normalize to have an interpreter in all of these events. Okay, I'm gonna go back if I can. Here. Okay, this is another thing that I have learned. Now I'm going to talk a little bit about what I have learned on this group. For instance, I have learned that the sign language is not international, it's very local. So this is an example of a video where I don't know if you can listen the audio. I think that I share with audio.
No, it's mute.
It's mute? Okay. I'm gonna try to do it again. Let me see.
You have 4 minutes. Take care.
Okay. Okay. It was mute, sorry. Okay. this is for a project where I'm working on.
Las galaxias están uniformemente distribuidas en el espacio. Forman una estructura en forma de esponja caracterizada por filamentos, muros.
It's a bit, the volume is low, but well.
Llamadas vacíos. Estos vacíos forman una parte integral de la estructura a gran escala del universo y representan aproximadamente el 60% del volumen del mismo. Los vacíos o voids nacen de la distribución primordial de materia al principio de la formación del universo. Y a pesar de su nombre, los vacíos contienen galaxias. Aunque no sabemos si las galaxias en estas regiones tan poco densas evolucionan de igual manera que las galaxias en entornos más densos, como por ejemplo nuestra galaxia, la Vía Láctea. El proyecto Cavity pretende conocer cómo se han formado y han evolucionado las galaxias en estos vacíos, y es uno de los proyectos delegados del Observatorio de Calar Alto en Almería.
So what I have learned about this then is first, you want to do just a video explaining a project, a scientific project, you can add subtitles, but you may know that people that have hearing impaired, they learn the sign language before reading. So having subtitle alone is not enough. You need an interpreter. Also, this is a project that is carried out in Spain. And then I realized that the sign language in Spain and in Chile are different. So I'm working in Chile. And then I want to tell to people here what I'm working on. But also I want to do this video accessible to my other collaborators in Spain. So what I can do is to add the two interpreters and also the deaf people can maybe have some kind of cultural exchange by knowing how some terms are, how is the meaning or how you can tell some things in other language, in this case, in Spanish. So I have a few minutes left, so I will just to say that in Sochia we have a working group for inclusion and gender, and we get with the PI Erika Lave funding from Astronomy, funding from the government for Astronomy program to generate a more inclusive astronomical community. So we are also bringing this to the professional astronomical community to train them on inclusion and accessibility. So following with the things that I have learned, what I have learned is that inclusion is an everyday job. We can all work on creating a warm and welcoming environment around us. For instance, when I can do in my daily work, I had to do research, I had to teach, I had to do some outreach and also some management. So for instance, on research, what can I do? What I can do is maybe in the discussion with collaboration to understand that different people may have different opinions. On teaching, maybe what I can do is to know before a class, to know if I have any student that have any special needs. And then I can prepare my teachers, my classes ahead so they can all understand and learn on the same way. In outreach, I can maybe have, if I'm going to give a public talk, maybe I can bring an interpreter. So in my outreach talk, I can reach to more people. In management, for example, in my position as Chilean of president of the Chilean Astronomical Society, maybe I can try to have representation in all the representative committees at different levels. Maybe from my position in the university, I can try to have more diversity in making decision bodies at different levels of the academia. So in the last minute, now we have the time for questions. So what I would like to do, or what I propose for the audience, is that what can you do in your daily work? So what is the activities that you used to do in your work? And just select between 1 or 3 things that you think that you can do to try to incorporate inclusion and make a more warm and friendly environment around you and for the others. So that's all what I wanted to do. Thank you.
Thank you very much, Maria. Very nice talk, and I agree fully, completely about that. This job is an everyday job. It's like a light pollution control. It's an everyday job. And one question I want to say, but you partially answer it, is about how the changes change when you have the opportunity to be the director, manager, or the person who decides about the topics to make the research or to improve the accessibility and so on. How change the things when you are the decision, the chair of the thing?
Yeah, if you can. That's why it's important to have diversity in committees that and making decision. We're making decision power. So you need to have diversity because they are going to improve, not to enrich. They are going to always to go with something new, something better that you maybe didn't thought before about that.
Mm-hmm. That's right. Can you hear me? Because I have some problems with my connection. Yes, Breezy, if you want to. Okay, Breezy, if you want to ask by yourself, yes. Turn the mic on. Breezy?
Yeah.
Are you there?
She can turn the mic.
Now I can.
Okay. Hi.
So, well, congratulations. It's wonderful, everything you guys have been doing. It's really inspiring. And I do have a particular question because I see you managed to do something that I try and I have not succeeded. So when there has been like a public talk now that, and which I am giving the talk, and the talk it's virtual, I have tried to contact, because of what you said, the sign language, it's local. So I have tried to contact the local group that can probably interpret it. But what they have told me is that they need to know everything of the talk with a lot of time beforehand and word by word, basically. And well, normally we just prepare things quickly and we're very, we put the idea together, but the words come more natural. So it's difficult. And plus you need more time than the time usually I have. So how do you manage these? Do you manage to give everything on time, or is it happen like, like instantaneous translation of the sign language? Thank you.
It's instantaneous translation, but I have to say that with the interpreter that we work, they work together for a very long. So at the beginning, we had to use some terms, and maybe the interpreter, they didn't know the terms because they don't have the sign. So sometimes you have to create some sign. And also in astronomy, because they are not used to use some terms that we use. Maybe they have to deletrate, to spell the term. But they cannot be like spelling all the time. So you have to do a previous work ahead, some previous work with them. But once you have some session of work, then it's easier for them also. So it's a collaboration work also with your interpreters.
Yes, connected with the previous question, Carmen Pantoja is also asking about how many sign language interpreters do you have or do you need for each talk?
Well, normally one, but it depends of the time. If it's going to be a very long activity, you have to have at least two, so they can be alternating. So about 15, not more than half half an hour each, because they are tired, so they need some time to have a break. So normally one for a normal talk, but if this is a longer activity, it's better to have two.
That's right. Well, this was the last question, so thank you very much again, Maria.
Thank you for the invitation.
No, congratulations for the great job. And let's go to the next speaker. Is the talk will be given in Spanish this time. So it's by John Carlos Mora Martínez, and it's how to use Salsaj software to perform photometry, astrometry, image processing in 3D. Well, the title is in English. I hope the slides also will be in English. So, John Carlos, it's your time.
Buenas tardes.
Buenas tardes. Hello. Good afternoon.
Muchas gracias. Voy a compartir pantalla.
Perfecto. Ahora te estamos viendo. Ya te digo. Perfecto. Estamos viendo tu pantalla.
Ok, buenas tardes para todos. Es un honor participar en el segundo congreso. Muy bien, hoy vamos a hacer una pequeña demostración sobre el software Salsaj, el cual nos permite hacer una fotometría estelar, astrometría y un procesamiento de imágenes en 3D. Bueno, voy a hacer la demostración. Aquí tengo ya abierto nuestro programa Salsaj. Este programa es especializado, el cual nos ayuda a implementar nuestra labor de docencia en profesores de secundaria e incluso en universidades. Yo soy John Mora, soy el director científico del grupo Astronomy. Nosotros somos Global Sky Partner de las cumbres Observatory. Y las cumbres Observatory es una red de telescopios a nivel global, el cual tiene distribuidos telescopios robóticos a nivel internacional. Usamos telescopios de toda la red. Estos telescopios están distribuidos en países como Australia, Sudáfrica, Chile y las Canarias, España, y en Estados Unidos, McDonald's y Hawái. Hoy vamos a usar las imágenes que hemos adquirido con estos telescopios. Muy bien, esta es una imagen adquirida con telescopios de Australia. En este momento vamos a hacer un ejercicio de fotometría, que son los mismos ejercicios que implementamos con profesores a nivel secundario. Vamos a darle brillo y contraste a nuestra imagen. Excelente. Aquí vamos a hacer nuestro proceso de fotometría. Aquí tenemos la estrella. Vamos a seleccionar nuestra línea. Trazamos directamente en todo el centro de la estrella. Dibujamos nuestro perfil luminoso. Aquí observamos tanto el perfil luminoso en la imagen izquierda como en la imagen de la derecha. Un círculo amarillo se nos describe. Vamos a anexar los datos de la fotometría, a forzar el radio de la estrella. Vamos a ubicar el radio de la estrella. Aquí nos indica que a la izquierda inicia la estrella desde 1560 píxeles hasta 1548, es decir, que tiene un diámetro de 12 píxeles, el radio sería de 6. Vamos a forzar el cielo a 12. Y las coordenadas de la estrella la podemos observar en esta parte. Muy bien, nos dice que en el eje X tiene 1541 y 1025 en el eje Y. Verificamos. 1551, muy bien. Procedemos a tomar la fotometría. Perfecto. En este momento hemos adquirido ya de nuestra imagen nuestro dato científico de la intensidad de la estrella. Ahora, esos datos permiten dibujar una curva de luz y así determinar si esta estrella presenta alguna variabilidad o no. Este software nos permite adicionar, observar muchas otras cosas. Ahora sí nos vamos a Analyze, Surface Plot. Y aquí nos vamos a detener un poco. Aquí nos permite realizar varios estudios en 3D y nos permite hacer un archivo, el cual nos va a permitir de esta manera poderlo imprimir en 3D, ayudándole así a maestros y estudiantes con deficiencia visual poder trabajar y poder aprender astronomía y sobre todo ya hacer investigaciones y estudios científicos, brindándole ya más accesibilidad. Muy bien, perfecto. Vamos a hacer otro ejercicio. Vamos a hacer un ejercicio con astrometría solar. Para ello, vamos a usar esta imagen. Muy bien, esta es otra capacidad del software Salsaj que nos permite medir y hacer trazos. En este momento ya estamos involucrando al Salsaj para que nos tome el diámetro estelar y así nos permita determinar diámetro solar y después poder medir sus manchas solares. Al igual que nuestro anterior ejercicio, podemos visualizarlo en 3D. Esto nos permite hacer muchos más estudios. Por ejemplo, en este momento estamos visualizando una mancha solar, el cual aquí nos permite diferenciar ciertos cambios de temperatura a nivel superficie, ya que estos campos electromagnéticos nos bajan un poquito la temperatura. Ahora, estas imágenes también las podemos imprimir en 3D. Esta es la mancha solar. También la podemos imprimir en 3D, proporcionándonos también este tipo de estudios. Podemos además incluso cambiar textos, gráficas e invertir toda nuestra información. Por último, tenemos una imagen que también podemos usar en nuestras investigaciones y vamos a hacer un ejercicio más o menos como nos queda impreso en 3D. Entonces seleccionamos con la herramienta de rectángulo Muy bien, nos vamos a Analyze, Surface Plot. Muy bien. Aquí nos muestra la misma imagen lista para trabajar y la cual podemos usar para llegar a la impresión en 3D. Perfecto, aquí le podemos dar altura. Podemos cambiar, nos vamos para grises. Y esta es la imagen que nos va a acompañar en la impresión 3D. Esta impresión 3D, aquí la tenemos. Muy bien, perfecto. Este software permite muchísimas más cosas. Nos permite trabajar imágenes en RGB, permite trabajar imágenes monocromáticas que son adquiridas por la red de telescopios LCO. Y nosotros somos especialistas en el manejo de telescopios robóticos y en el uso de este Salsaj. Bueno, con esto ya terminamos. Muchas gracias y esperamos responder cualquier pregunta. Muchas gracias.
Muchas gracias, John. Yo tengo una pregunta. Después, I will ask a question and after that I will try to translate. ¿Este software es público? ¿Se puede, es propietario?
Sí, es público. Nosotros trabajamos sobre todo para la enseñanza de nuestros docentes en el software totalmente libre. Lo pueden incluso, bueno, vamos a poder, por ejemplo, aquí hacer un ejercicio. Lo pueden descargar aquí, Salsaj.
But, ¿es open source?
Open source, sí. Okay. Lo pueden descargar de esta página. Bueno, esta es la página. Salsaj es un programa de la Hanson Universe, que es un programa internacional encargado de la enseñanza a maestros para que sea más accesible la astronomía a nivel de las aulas y personas con deficiencias. Entonces, aquí pueden ingresar. El software está especializado y está en versiones en Windows, Mac y Linux.
Ok. Bueno, aquí hay personas como Carmen Pantoja que desean contactarse con vos, así que luego ponemos tu correo electrónico en el chat, si te parece.
Sí, perfecto.
Y bueno, Alison, well, the question was about the usability and accessibility of the software, which is written in an open source. So it's an open source resource, so you can download it from the website that John mentioned, but we will put, actually, sorry. Oh, yeah. We will put the link to the resource in the chat, just to the people who is asking for. La otra pregunta que tengo muy breve es acerca de la experiencia que han tenido si han aplicado las herramientas, los recursos que han creado, por ejemplo, las imágenes táctiles, con gente con problemas de visión o en escuelas, y si han tenido la experiencia de testear esos productos.
Sí. Nosotros, por ejemplo, hemos iniciado cursos en población vulnerable. Nosotros vamos, en Colombia hay minas de esmeraldas, pero la cual alrededor de las minas de esmeraldas, estas poblaciones no tienen muchos recursos económicos. Las escuelas y los colegios no cuentan con accesibilidad a la astronomía. Nosotros hemos implementado con estos profesores y alumnos cursos de astronomía y se nos presentaban alumnos con estas discapacidades. Entonces implementamos estos cursos para que ellos tuvieran más accesibilidad. Inicialmente teníamos 2 alumnos, en este momento contamos con 14 alumnos en la región y ha sido excelente, Al principio no es fácil, tuvimos nosotros mismos que aprender cómo teníamos que dictar estas clases, pero ha sido fascinante y este es uno de los proyectos que tenemos. El próximo año vamos a implementar otros.
Okay, John is talking about the teaching learning process in the contact with the disabled communities in general, and the testing of the products with the people directly to study the impact and to have the feedback to improve it. Well, muchas gracias, John. Por favor, poner en el chat los links a los recursos que mostraste en internet y también tu correo electrónico, si nos haces ese favor.
Muchas gracias.
Muy agradecidos. Thank you very much. Okay, let's go to the next speaker, who is Breezy Ocaña, another good friend. She is from Dominican Republic, but living in United States of America, of North America. And the talk is about the Caribbean astronomy for inclusion, transforming theory on inclusion into concrete actions. Breezy, the time is yours.
Hello,
Are you
everyone.
there? Yeah. Okay.
Yes, I am. Can you hear me?
Yes, perfectly.
Okay.
Let's go.
Okay, let me share my screen, see if everything, there.
Yes,
okay.
Perfect.
Can everybody see? Perfect. Well,
Yes.
thank you very much, Beatriz. And well, thank you for the organizers also for giving us the time to talk about our group in this conference. And as Beatriz said, it's Caribbean Astronomy for Inclusion. The topic is transforming theory on inclusion into concrete actions. Sorry. Yeah. First of all, let me quickly introduce CAI, which is how we usually call it, Caribbean Astronomy for Inclusion. And we are a group of astronomers and amateur astronomers from the Caribbean region. So far, we have Honduras, Haiti, Dominican Republic, Puerto Rico, and Trinidad and Tobago. And well, yes, why it's important to talk about inclusion? Because according to the World Health Organization, 15% of the world population has a disability. And according to UNESCO, 19% of the children with disability do not attend schools. So this is a high number. And the fact that they're not attending schools could be that also there's some support needed in the educational system. Sorry. This plot here, it's a plot with the percentage number of disability of unemployment among people with disabilities in Dominican Republic, Haiti, Puerto Rico, and Trinidad and Tobago. According to the survey in 2013 for Dominican Republic, around 60% of the people with disabilities are unemployed. In Haiti, from a survey from 2013 as well, the amount of unemployment is around the 60% as well. In Puerto Rico, according to the survey of 2017, it is around, it's higher than 80%. And in Trinidad and Tobago in 2019, it was around 95%. So there is a big number of unemployment among people with disabilities. And we need to think that maybe the people that are in the disability spectrum but are employed could have entered the disability spectrum after being employed or perhaps after finishing the education. So our goals are to target the transition into the work field, skill acquisition, capacity building. We also want to create a community where astronomy and its practices are promoted with people with disabilities. We want to offer materials, resources, methodologies, etc. We also seek to increase the accessibility for inclusion and close the gap that already exists in the people with within the people with disabilities in the Caribbean region. And how are we planning to do this? Well, we plan to offer teacher trainings on how to teach astronomy to people with disabilities, inclusive astronomy. We want to create a repository of materials in astronomy for inclusion. All of these materials should be in a web page that we are in the process of creating. And this web page, we want it to be accessible. And there you would have a point of contact for the different countries in the Caribbean regions and also materials. And we want to have enough materials also in the local languages because the Caribbean region, it's a very diverse area. And in the Caribbean, we have different languages as well. So we want to develop materials that are local to the islands as a group and to each island individually as well. So as a long-term action, we plan to expand the connection between the different countries in the Caribbean region. We have representatives or have more representatives in the different Caribbean regions, different countries, and to be able to train as many teachers as possible in didactic inclusive astronomy, offering workshops. So we want to create material for educational purposes. These materials are focused for early age elementary school, secondary and university levels, and everything can be eventually be found in this webpage. Now, you've heard throughout this conference about the light sound, and you can also see a poster, which is in the poster section about the light sound if you want to know more details about it. It was designed at Harvard University and as a tool for the blind and visually impaired community to experience the solar eclipse in 2017. But as you probably heard also in the conference, it was used in Chile and Argentina in the 2019 and 2020 solar eclipse as well. So a model of the light sound has already been built, or it's being built in Trinidad and Tobago, and we just got it in the Dominican Republic. So the idea is to build it and to start designing lessons plans. And and we want to design lesson plans using the light sound as a tool. The orchestra, the orchestra is another instrument. It's a sonification device that converts light to sound, but this time it's based on colors. So blind individuals in Puerto Rico have aligned themselves manually a telescope. And they have done this by listening to the color of the stars. And they can not only align a telescope, but they can also acquire data. Another tool that it's very useful, it's the CARDIS, which stands for Coordinates and Relative Dimensions in Space. And this is a 3D tactile grid that can be used to address many perceptions problems. And it is a low-tech tool. The materials are really easy to find, and it can be built, people can build them themselves. And it has been designed by Dr. Kathy Eastwood and Wanda Diaz. This is an image of this CARDIS. And it can be used in education in different levels. For example, it can be used in middle schools to study or to learn about areas, volume, to discuss geometry in a tactile way. It can also be used in high school and university. For example, talking about the conversion between Cartesian and spherical coordinates. It has been proved already and it has worked. So the CARDIS has already been sent to different islands to different regions of the Caribbean. It is already in Haiti, Dominican Republic, Trinidad and Tobago, and it's already in Puerto Rico. It has been distributed freely by Free Matters for the Blind and Physical Scheme. And right now we are in the process of working with the teacher to build it together, to work on the, helping them understand how it works so that then they can use it in the classrooms with their students. I believe that this is good not only when you have a problem, like when you're blind or when you can't see the image in the book, because this is also a 3D perception. And then when you have that, even when you can see, this helps you to imagine the perception problem, which sometimes is difficult for some people, independently of their diversity. Sorry. So also there is a book that the students from the University of the West Indies are leading. This book is it's in the process of being written right now. It's about astronomy, but it also has mathematics and physics. And we are explaining the concepts of these topics in an accessible way without sacrificing the scientific content. How much? Okay. So as an example of activities that we have done for the elementary school, it's the solar system on a rope. This also, you guys have seen them throughout the conferences. And the reason you guys have seen this is because it's a very useful way to explain the dimensions in space and the distances between the objects in the solar system particularly. But what we are trying to do is to build them together with the students. And we take, for example, as we talk about scales models. So we talk about making the object in a size, but respecting the dimensions. So we talk about these mathematical concepts. And to making the scale model, we choose a unit that is, for example, the astronomical, the distance between the sun and the Earth. The astronomical unit is the size of my finger, for example, or the finger of the person making this model. And when you have a distance that is something that you know very well within your own body, then you can relate more to the final distance from the solar system between the sun and the last planet of the solar system, for example, in this particular case. So to see that if the sun and the Earth would be my finger apart, that the solar system would be taller than my entire body, it's an experience. The same, very similar activity we have done with the moon and the size of the moon. If we assume that the moon is the size of my fist, that the Earth is the size of my fist, then the moon is the size of my thumb finger. And then understanding that between the Earth and the moon, if I open both of my arms, it's still larger than that. It's also another way of being inside the system and relating it to the size that I know very, very well, that are parts of my own body. We're working with the Sustainable Development Goals. First of all, quality of education, right? Because we are working with the schools with these, the materials with the schools. But if you are working for a better quality of education, then you're automatically working with decent work and economic growth, and also reducing inequalities eventually in the long run, which is what we're looking for. Thank you very much for your attention. I leave here an email and contact information.
Great, Breezy, very nice. I'm very happy that to see the advance in the creation of the resources and tools for Caribbean, which is part of a long-term project, I think. And I believe that many of your partners are here in the meeting, so it's good to see everybody. Some of them. Well, I don't know if we have any question in a chat, not for a moment, but well, please put the question if you have. I would like to ask about if you want to share with us, you have some minutes, the process of the creation of this working group, which was part of, yes, because you you started with several things all disconnected, and finally you include many people. And also, if you want to share the experience, because in Caribbean there are a lot of languages, and it was a decision.
There are a lot of languages, yes.
Yes, a decision to take about how to create this group, a special group of activities. Please share with us that.
Yes. Sure. And if anybody, I know I've seen some of us here. I don't know if you guys want to participate as well. I have no problem. From my perspective, yes, it has been it was a little difficult, but I think always starting something, it's not easy. We are still in the beginning. So most of the things I have presented, either we have tested it. More testing would be wonderful to improve the activities. Some of the things are in the process of being made, like I showed the light sound, and it's just been built in Trinidad and Tobago. We just received it, so we haven't even started. I received it yesterday, to be honest. So, so we are really starting. But I think it has been the beginning a little complicated. But I think we're coming together. We have a common goal. We all want to, support the education of our nation, of our countries. We believe that astronomy is an amazing tool to start, not the only one, of course, but through astronomy, you open the door to so much in education. So I think using astronomy for these, it's great. People are curious about astronomy. Astronomy, it's enchanting. And so... And yeah, we're still working. I mean, we're still creating this group. I'm really happy to be here because it is the first time we are in a conference, and we hope to keep coming to conference with more and more.
That's right. Well, thank you very much. We have no more time, but congratulations and good luck with the activity.
Thank you.
So I invite you to go to the next talk. Here I have this. This is my first book about inclusive astronomy. It's by Noreen Grease. Yes, this is really my first book about the possibility to make inclusive things in astronomy for all the people. Here I have the pleasure to introduce Noreen Grease in her talk, Accessible Astronomy, How to Adapt Activities for Blind and Visually Impaired Learners Using Low-Cost Materials. So thank you very much, Noreen, for being here, and here is your time.
Thank you. Thank you for that lovely introduction, Beatrice. Let me share my screen. Let's see. Okay, here we go. And we go in presenter mode. Let's see. Mm-hmm. Okay, can you see the slide?
Yes, perfectly.
Yes. Okay. So I'm going to speak on accessible astronomy, how to adapt activities for blind and visually impaired learners using low-cost materials. And I'd like to start off by the theme of our conference, Astronomy Beyond the Common Senses. So the senses, we have vision, touch, hearing, smell, and taste. And we can combine vision and touch through tactile images. If a tactile image can generate a picture in the mind's eye, then you have vision. Now, when you are making tactile images, you need to consider what is the goal of the tactile image. Are you trying to make an exact copy of a print image, maybe a section of a print image, a general representation of the image? Who is the audience? Are you making the picture for young children, students, adults, families, people who are blind, people with low vision? Under what conditions will the tactile image be used? Will it be outdoors, indoors, outreach, classroom, humid environment? as we heard in an earlier talk, sometimes it rains and you're outside, so you need to plan for how your tactile image will be used. How many times will the tactile image be used, and by how many people? One time, during 1 year, over many years? Well, I like to have some supplies available to make tactile images. And so some of the things that I like to have are a pair of scissors, some puff paint, Velcro dots, a permanent marker like Sharpie pen, a ruler, tape, and glue. Now, depending on the type of project you have, you may need different materials. For example, for the flat supplies to create tactile pictures, I like to have rough glitter paper, which feels like sandpaper, is very rough. Textured foam paper. You can actually buy foam paper that has textures already assigned to them. Velcro strips as opposed to the Velcro dots. Rubber shelf liner paper, which feels very tacky and rubbery. And smooth foam paper. Other things to consider when making tactile connections between objects in a picture: yarn, pipe cleaners, glitter glue, beads, brass fasteners, and string. So these are kind of the things I like to have around when I'm making tactile pictures. And I'm talking about not using a 3D printer, just to make a tactile picture, which could possibly be duplicated on a thermoform machine, but at least you would have one. Okay. Now let's get my slide to go forward. There we go. Now I'd like to talk about an example, and the example is the Big Astronomy Project. You may be familiar with that. It's at bigastronomy.org. It's a program, a grant-funded program that involves people in the United States and people in Chile, and it's promoting the wonderful research that is being done in the observatories in Chile to inspire students to consider STEM careers. And the project includes a planetarium program, different webinars with researchers, and also informal activities. The group brought me in to work on the informal activities. The activities were already created, but they were not accessible. So I created an accessible adaptation kit. And I'd like to give an example by showing you. Okay, so the activity kit, there's actually a box that was sent to people, but all the files are also online. And I created the accessible modifications. And the activities I created modifications were for Visualize Our Galaxy, Clues to the Cosmos, Good Light, Good Night, which is about light pollution, Dark Sky Wheel, and Legends in the Sky. So let's take a look at one activity called Visualize Our Galaxy. In the kit, people received an umbrella with an artist rendering of the Milky Way galaxy on the umbrella. And the challenge for me was how to make this activity accessible. Well, I thought long and hard about the umbrella and to make modifications on the umbrella, but instead I decided to take a different strategy. In the activity, there's a page called Notes for the Presenter. And in that note, it says you can print out a model of the image that is on the umbrella, and it gives you the website bit.ly/bigastro. So I decided to use that printout and make two different versions of the galaxy. This is what the printout looks like. So this is the same picture that is on the umbrella. It's the artist rendering of the Milky Way. There is a circle which represents the closest stars, the stars that we see to the unaided eye from Earth, and in the center is the location, the center of that little circle is the location of the solar system. So based on this image, here's what I came up with. A tactile foam galaxy. For this project, you need one sheet of, now this is called Stick It, but what it means is it just has a sticky backing, or you could put glue in the back. So one sheet of felt with an adhesive backing, 1 sheet of smooth foam paper, 1 sheet of glitter foam paper, that's that rough foam paper with an adhesive backing, 2 round adhesive foam stickers. You want one to at least be the same size as the circle for your galaxy, that circle that represents the closest stars that we see from the Earth, a small brass fastener, and you'll need scissors. So basically what you're going to do is you're just going to cut out a shape that looks very similar to the galaxy with the glitter foam paper. You're going to peel the back off and stick it right onto the felt. So the felt will feel smooth, the galaxy will feel rough. Then you want to cut out the center bar of the Milky Way, and you want to stick it onto the core of our galaxy. And the last thing you need to do is to attach the little circle, the little round foam circle in the spiral arm to represent the location of our solar system and the stars we can see. If you have a brass fastener, use that. If you don't, use a second small piece of round sticker and place it on top, a little bit smaller. And when you put it together, it looks like this. Okay, so again, what you have is contrasting textures. You've got the smooth background of the felt, you've got the rough texture of the glitter foam, and you've got the smooth texture of the center bar of our Milky Way, and then you have the location of our solar system and the galaxy. Now, another way you could do this is by making a copy of the picture. I like to print it out on 11 by 17 and laminate it. So go to a store, office store, and laminate it if you can. Then I use a bottle of glitter glue. I use a bottle of slick fabric paint. So it might be called glitter glue or fabric glue, and one will be slick, which will be smooth, one will be glitter, which then will dry rough. Again, the 2 small foam stickers and the small brass fastener. So with the glitter glue, you're going to simply outline the spiral arms of our galaxy. And then with the slick glue, you kind of have a big blob to make the barred spiral in the center. And then attach your round adhesive foam and your brass fastener for the location of the solar system. And when you have that, this is what it looks like close up. Now, the very important thing about this is don't touch it for 24 hours. If you do touch it before 24 hours, you will have a tactile fingerprint, and that's not fun. So you want to definitely must let this dry overnight before using it. So again, just to reflect back, when you are making a tactile picture, you really need to consider the needs of the project. First, you need to determine that you need a tactile picture. But again, decide what is the goal of the tactile image? Who is your audience? Under what conditions will the tactile image be used? How many times will the tactile image be used? And how many people will use it? And now, with these ideas, hopefully you will be able to make topics more accessible using inclusive, low-cost materials. And I'm going to show you, I just have, let me stop sharing the screen here for a moment. And my website for other projects is www.youcandoastronomy.com. Let me stop sharing for a moment, and I will show you, I have behind me the glitter foam galaxy. And also the other one, which is the laminated one. So these are just 2 different ways to make the galaxy, and it's just one example of what you can do with these kind of materials to just always have around. And with that, I'll be happy to answer questions.
Great. Very nice, Noreen. Thank you very much for your talk. Let's see if we have any question, but I will be always very happy to new your books. This is Touch the Universe, for the people who cannot see. Touch the Universe was my first a tactile book for astronomy, and was an inspiration really. And I know for many other people. So thank you.
I should say, Beatrice, that book is out of print now. However, there's a new. I'm just going to grab over here. There's a new.
Let's see.
There we go. Touch the stars. This one is new and is available.
This is the Major Ursa. We need a cover with the southern constellations.
Oh, okay. Yes, I'll do that next. That's right.
Next year. Well, let's see if you have any question for a moment. Have not, but you mentioned that you are working with people in Chile, but you are also working with people in other countries, or is your line of action?
Well, for this particular project, I was brought in by the group from the United States that was working on the project for the informal education activities, and they had it's easier when you're starting to create the activities from the start, but the activities had already been created, and they were concerned that they were not accessible, and so. It is an international project, but the people who brought me in to do this work are, I think, from the United States.
Okay, and one more question, because we have 1 minute. It's about the other senses, not just to touch and to hear, about the smell and the taste. Did you experience with this or not yet?
No, there's nothing with taste, but I don't think you should be tasting the glue. But I think it's a very interesting idea, and something that I'll have to think about.
Okay, yes, I agree. We need to use all the senses. So thank you very much. Thank you for your talk, and congratulations, of course, for your work, and you are an inspiration for many people. So thank you very much.
Thank you, Beatrice.
Well, let's go to the next speaker. It's a Spanish speaker, but I am sure that she will talk in English. Is Carla Fuentes Muñoz from Chile, with a special project we hear about that, Dedoscopio, an inclusive project dedicated to bringing tactile astronomy talks. So, Carla, are you there?
Yes, here I am, Beatrice. Thank you very much.
Okay. No, you're welcome. Try to share your screen.
Okay.
Okay.
Yes, right? It's okay.
I can see you. Yes, I can see, not in the presentation mode, but your talk is there.
Yes, excellent. Thank you very much for this space. And I am very happy to be here sharing what we are doing in Dedoscopio with this project that is dedicated to bring astronomy talk and more. This project, I am not the only person involved, but also it's Pamela Paredes Sabando. We both are financial by Titans, the Núcleo Millennial Fund. And there it is. So Dedoscopio was born in 2018 as a project to contribute to make more inclusive the astronomy, and we are doing it through multisensorial talks. Here I show a picture of Pamela and me with our material in a stand where we show our material for different people, not only for blind and visual and impaired community. This is a little bit slower here. Okay. And as I said, we do tactile talks where we create our material. We also use printed models, but we are not using too much. Our main goal is to do and use homemade models. And we also use a lot of the materials that you saw in the last talk, a lot of glitter, a lot of textures. We use sand. We also use foam paper and a lot of feather balls. And I show you here an impress pictures of the Milky Way, and we fill them with different textures to represent the Milky Way in an all wavelength. We also create this very, I don't know, maybe fun material to find asteroids in a field of view with stars. So in the top part of the square are a lot of dots that represent a field of view with stars, and in the bottom part, on the other part of this square is the same field, but you have to find the dots that are moving, so they are not correlating between one part and the other with your fingers, and those are the asteroids that you will find in this field that we are presented. Also, we use, as I said, different kind of materials. Here we present a solar system with the different planets and their orbits. But our main thing that we want to highlight is the asteroid belts. So we represent them with little noodles. And we also want to highlight them with different contrast colors with the background of this material. Also, we use different with wood. We want to highlight the different textures as I show you in this image. So far, we have 6 talks with different topics. So we have the asteroids. We also talk about the black holes. As I said before, the spectral electromagnetic. And in one point here in Chile, Mars was a very highlight topic. So we want to also talk about it, and all the robots that are landing on it. So I show you a picture of Mars and their moons in different scales. And as you heard before, the solar eclipse that has a very impact here in Chile. Our main goal and our main target audience is visual and blind and visually impaired people. And we were going all across the country, Chile. Here I show you our country and the different groups and different localities where we were being. So from the north and very south in Chile, we've been talking and bringing this experience for everybody. I want to tell you that the BVI community here in Chile are getting together in small groups. Some of them are very far from the main cities, so they are very rural towns. And they get together more or less 10 people in the different localities, and they get together once a week or sometimes once a month just to hang out and share different experiences. We try to reach them. It's very hard for us to reach them and contact them. They are not very into the highlight into the society. So it's been hard to reach them. But we also like to share with the teachers to show them our material so they can reproduce it or maybe change it in for their own use. Also, we like to share our experiences and our talks with professional astronomers in different scientific conferences. As I show you here in a picture where all the astronomers are sitting in front of us with their eyes covered. Well, I will miss this part, but during the lockdown or during these 2 years of pandemic, we have been also doing a lot of activities. Our main activity, or a very big activity, was the total solar eclipse. We create a kit, Eclipse Curioso, where we put in a box different tactile material and distribute it to the people that live in the total eclipse area. I show you here 4 examples of the people that receive it, and we also count with the light sound that you hear before. And I want you to highlight also that we are not alone in these activities. We count and we always work with a lot of people. So, for example, for this kit, I show you just a few people that it's helping us or were helping us. Also, one of our one activity that we are very happy to show you or to share you, it's our audio reading club, where during this year we could be able to do an activity with kids. It's not very easy for us. It hasn't been very easy for us to reach kids. They are very inside of the educational system here at Chile. So they are not very easy to read, to found. And our club, it's based on audiobook, The Little Princess Universe, and that has been translated to the Spanish and also converted to an audiobook. So with 6 chapters, we share with kids, as I show you here. They had to connect through Zoom through 7 seasons where we listen to this audiobook and we also talk about it. We reached 33 kids, and our very exciting news is that we reached also not only in Chile, we went to La Serena and Santiago in Chile, but also with a group in Bolivia. So it's been an activity very exciting for us because this allows us to reach a lot of kids. And also what the pandemic has got us, it's a new collaboration with Las Campanas Observatory, where we create the talk about telescope. They bring us one of the telescopes printed in 3D, and we could able to produce like a small kit with different topics of astronomy and also with the telescope, and we'll talk about it through Zoom again here at the Región de Coquimbo, where the observatory is. And the last talk that we have was in presence with all the kids here at La Serena, also with the same kids, and you can see the material here with the kids. Just a conclusion, the material that we prepare, we we understand that it's not only for BVI community, but it's also for everybody. Everybody likes it. Everybody have fun with it and learn astronomy with, like, using, as before you said, with all your senses. So thank you, and please contact us to this email for more activities and, I don't know, everything that we can do. Thank you.
Okay, thank you very much, Carla. Very nice job. I know you invest a lot of time to do this and to reach all the corners of the country, which is very large.
Yes.
It's difficult to travel along Chile, so it's a nice job. Thank you very much. And I don't know if someone wants to make a question, but one thing I would like to ask is you mentioned that you was born a couple of years ago, more or less, or 4 years ago. So how do you evaluate the impact of the activity? Is through the people who join the project, or and also the impact in the different communities, in the schools and the clubs, etc. How do you evaluate that?
Yeah, we always try to do a brief questionnaire before and after our talks, and also to ask them some feedback. What do they understand? And also, what do they didn't understand? What was hard in the material to get? And especially if they have another talks, like scientific talks, like the one that we had. And for our surprise, they were very happy to be included in some news that they hear in the local news or in the newspaper, the radio. So they were very happy to understand a little bit more about the universe through these materials. And yes, we try to, I think it's hard for us to measure like a real impact more than their feelings.
Okay, nice. Well, yes, the evaluation is one of the most difficult things when you teach with any profile and with any resource. So, well, but congratulations, because I know you are very, very well known in the country and outside the country too. Thank you.
Yes, thank you. Thank you very much.
Well, if there is no more questions for Carla, I invite you for the final talk. Well, all good things end, and the bad things also end. So, so it's the end, almost the end of the meeting. Vanessa Moss has a responsibility to talk for the final talk, the last talk, the path to a more accessible and inclusive future of the meetings in astronomy, which is very appropriate, I think. So, Vanessa, if you are there, you can share your talk.
Thank you. Yes, it's a lot of responsibility, but no, I'm looking forward to.
But it's a good topic for the end of the meeting. It's a very good topic. So,
yeah. So I'm just sharing my screen. 1 second. Oh, I forgot to do the thing. I am not thinking right now. My brain is just not working. All right, sharing sound, optimizing for video clip. Yeah, I was like, you have 3 things to do, Vanessa. You can do it, but nope. Okay, let me just make sure I've got the chat. I guess let me know pretty quickly if the sound's not coming through for some reason so I can debug that. Otherwise, I think we can go. So let's... Hi everyone, I'm Vanessa. I'm from CSIRO in Australia, and I'd like to thank the organisers for giving me the chance to speak with you today about what more accessible and inclusive meetings might look like in the future. This is work that we've done under the umbrella of the Future of Meetings, and so it's great to be here with you today to talk to you about it. I'd like to take the chance to pay my respects to elders past, present, and emerging. I am dialing in from Darug country here in Sydney, and other people who have been involved in TFOM work are from all across Australia. So these are just some of the places or the countries that they are also representing. A little bit of a background about me, just for context. So I work for CSIRO Space and Astronomy. My main role focuses around ASCAP science operations, amongst other things. I also coordinate duty astronomers to support the compact array. I am the chair of the Future of Meetings Consortium or Community of Practice, which is what we are doing since the symposium itself. And I'm also an exec member on the EMCR forum in Australia, representing early and mid-career researchers. A quick overview of this talk. So I'd like to quickly cover our old normal and what that looks like and what it means, for the future. Talk a little bit about the future of meetings and what that is, some of the outcomes for it, and then frame it around what are the implications for astronomy and for accessibility in astronomy, and what are some next steps that we can take. So just to kind of throw back to early 2020, and, I guess different people's experiences will vary, but for me, it was kind of business as usual. The very last thing I did before lockdown started here in Australia was I was in Perth for a number of reasons, for training, for a science retreat, for collaboration visits. So literally the very last thing I did before COVID really set in was travel. I had a number of trips planned for 2020. This included going to, to Italy for the FISC H1 conference, to Georgia in the US for high velocity clouds, to Astro for collaboration, and to Italy again for ERSI. So this was kind of just our normal, right? This is what's expected of a career in astronomy. And so this can take lots of different forms. There's lots of ways in which we travel. It's seen as part of our careers. It's collaboration, sometimes unconferences, so more focused on collaboration around the content rather than just conference itself. We're doing a conference right now. Schools for training, observing. So there's a lot of kind of, I guess, assumption that this is how we do things. This is how we collaborate. This is how we meet. And so that was really challenged. And so one of the things that is really important to ask ourselves now as we stand at, kind of the edge of what does a new normal look like is our old normal, which was all of this travel, across the countries that we live in, across the world, is that the right normal? Is that what we want to encourage? I put the logo for Astronomers for Planet Earth here on this slide as well, because wrapped up in all of this are also considerations of sustainability. And if you caught Travis's talk yesterday, then you would have also seen some of that covered too. And the other questions we have been trying to explore in the work we're doing is what happens when you're not in the room? What is the experience? We're all, I think, thinking about what hybrid and good hybrid looks like. And how do we make sure that we don't kind of, I guess, reinforce these hierarchies? As was pointed out in talks yesterday, there's a difference between having access to something and actually being included as part of the conversation. And the other question is, can we actually effectively connect with people even when we're apart? Can we have those meaningful interactions? Can we be in the same virtual spaces together? That's obviously one of the challenges people talk a lot about, is how do you reproduce that in-person feeling of being together with other people? So to kind of explore these questions and more framed around our key themes of accessibility, inclusivity, and sustainability, we held a symposium in September 2020, completely online, focused entirely on what the future of meetings might look like. Throughout the whole process, we were always focused on what are the outcomes, like how can we learn from this and how can we share those outcomes to help everyone make their meetings and interaction in the future better. So we wrote a report, we also wrote a nature comment, and we came up with a set of principles which we refer to as DISERV, which capture a lot of our lessons learned and advice that we think can really help if you're designing an interaction or a meeting or a conference or anything from scratch, taking into account those different themes and making sure that it's as inclusive as possible and also is going to achieve the best outcomes. So I'm not going to go through DISERV in detail. We can circulate resources, but very quickly, it's digital first, which is allowing people to connect, like using technology to its advantage so that you're minimizing that gap in experience regardless of where people are. Accessibility, inclusivity, and sustainability as key goals. Experimentation to make sure that you are kind of aware of the different tools at your disposal to solve a problem, and then kind of, I guess, absorbing that into choosing the right tool and approach for the situation. Value is about, maximizing your value for investment. So do you need to pay to outsource something? Can you do it in-house? How do you balance that to make sure, you're getting the best value, and that it's not always just about money. And evaluation is from the very beginning and through to the end, is whatever you're trying to do meeting its purpose. So there's lots more information we can circulate if you're interested. I think if we then go straight into what does this mean for astronomy, there's a lot of different questions that sort of come up when you serve astronomy, so to speak. One is, how do we, in digital first, how do we actually effectively conduct our astronomical practices across states or nations or globally? And we've been doing this for a long time, but are our old practices the most effective here, or can we adapt? And in terms of accessible and inclusive, which is obviously the main theme of this meeting, how much of our existing scientific workflows have been designed traditionally to include or exclude, and how can we make that better? And, already in this conference, we've seen so many initiatives that have really been designed to take what has been previously assumed, okay, this is how you conduct astronomy, this is how you learn about astronomy, and really change that. So I think that's really exciting to see, and hopefully becomes more widespread throughout everything to do with astronomy and other sciences. Sustainable, how do we make sure that we're doing the least harm to the planet in everything we do? Are we making sure that we are flexible in our field in the changing face of tech, which is changing very quickly all the time? Are we distributing funds in the best way? When we have limited resources, where do we need to distribute either funds or just general resources, in different areas? And evaluation, can we adjust and assess what we're doing and make sure it's also having the maximum impact? So again, this slide is not meant to be read or consumed in detail, but the point of it is to show that there are benefits, many benefits for accessibility and inclusivity in our current formats. So for example, distributing opportunity more fairly, minimizing barriers for access, changing the ways we expose ourselves to a global community, being more connected, changing collaboration. So those are some of the positives. More inclusive of neurodiversity, I think, is really important. And there's some resources that I've linked on the slides and can also share. But there's also challenges, right? And I think, as was mentioned yesterday during Travis's talk, it's also for everything that can be more accessible and more inclusive about online interaction, you have to be really careful that we're not kind of baking in new kinds of inaccessibility and new kinds of exclusion. So I would say that there are challenges that everyone's been pointing out with the online, things like, trying to reproduce what we would do in person online, harder to reproduce that serendipitous interaction. Technical difficulties can be a challenge. It's not the same as being there. It's harder to concentrate. So these are all real problems, but actually what we found in the future of meetings is that they do have real solutions and they can be mitigated. And in the future, they'll be mitigated even better. So it's worth, I guess, finding the challenges and solving them, because the benefits are really what we're seeing, so much more value. And it would be good for us to, get there and really just have more inclusive astronomy for everyone. So to talk about what are some of the next steps, like where do we see, what can you do now? In our conference, we had 3 days themed around today, tomorrow, and future. And I think that also links in very well with what the next steps are for us as a community to really be trying to put this into practice and looking to the future. So today, we can already be thinking about what are we using in-person interaction for, and maximizing, the value of that, because we know it comes at significant cost. So consider who's being excluded and is it worth it? We can use existing accessibility tools. There are already some really great ones out there. They're going to get easier. Being aware of them and making sure we're thinking about this from the start is important. We can offer support, ask what people need, and just be more inclusive of those needs when we design whatever it is we're doing. And just, really using face-to-face sparingly, not just like in person, but also just live interaction. We can use asynchronous tools to communicate. We can share things in advance, and we can really, I guess, kind of already change a lot of our assumptions about how we interact with each other. tomorrow, so in the near future, over coming months, years, we need to, I guess, see where we fit in as a field with global effort. Everybody is thinking about this. Everybody is thinking about, what is the future post-COVID? So I think really connecting in with those global lessons learned, advocating digital first, so thinking about minimizing that gap in experience if you have especially hybrid modes, trying out and implementing new practices and finding out what works. One of the most exciting things about this is that there are no solid, there's no best practice, it's still evolving. So there is a chance to contribute to that and to really help define what best practice looks like for the future. And so from our perspective, also experimenting with DICERV is great because we think it can be a useful framework, but it's something we want to iterate on, and we'd love to hear feedback from people who have tried to use it or think about it in their interactions. And on the long-term scale, we need to be looking at adapting our funding structures to reflect the needs of the community and, how do we change some of the assumptions about what a successful career looks like when it's so inextricably linked to travel or to exclusionary practices. So changing our funding structures to support new ways of interacting and working. Mixed reality is going to be in the mix. That wasn't necessarily meant to be a pun, but it's going to be in there. It's already in the next couple of years, it's going to reach serious critical mass and it's going to change the way we collaborate. Also making sure that inaccessibility doesn't get built into these mixed reality tools. We need that to be part of the conversation from early on because there's a lot of opportunity there, but there's also a lot of risk that we just, continue existing practices of inaccessibility. Creating new support paths. So making sure that we're minimizing those barriers for entry, especially in, the EMCR community. And also just taking steps towards enabling global astronomy in a way that's never been possible before. So location agnostic collaboration, minimizing the effect of funding gaps, all of those kind of things. These are really the future of our field and what we can be doing to both protect that and improve on it. So make a new normal that's better than the old normal. And kind of mixed in with all this is the concept of, so much of our limitations in when we try to interact online is because we try to reproduce this being there. We think in person is what is needed, but actually if we can go beyond the concept of being there, if we can think, what is it we're trying to achieve and what is it that online allows us to do that in person never did? That actually will be a great opening of new opportunities for how we collaborate in the future. So just to very quickly summarize our key recommendations, and very happy to take questions and discuss more. So consider the role of DICERV in what you're doing. Aim always to include and think about who you're excluding. Use in person carefully and wisely where it is most appropriate. Prepare for the future of work, which is, a broader context in which we exist, and it's going to become more and more relevant. Maximizing location neutrality. So, where you are shouldn't matter as much, and minimizing human dependency. So, what can we do to, minimize the places where we've traditionally had like bottlenecks in, human dependency or so, and also accounting for the growth in mixed reality, which is going to change a lot of the ways that we interact. So that's everything from me. I've been really excited to see so many things over the last couple of days and looking forward to seeing astronomy become even more accessible and inclusive in the future. And I'm really hopeful that some of the work we're doing in the future of meetings can help contribute to that. So thanks very much and looking forward to chatting with you more. Thanks.
Thank you, Vanessa. I know that you were chatting in the chat with some assistants. Well, this is another resource that we didn't explore these days because it's a pre-recorded video, which is part of the new technologies, and in many workshops and symposiums and so on, is a very used resource. So you are the first and the last one to use the pre-recorded video, but perhaps you want to share with everyone why you did this and what do you think about this resource, because it's IAU is using a lot this in different platforms.
Yeah, so I guess so I put some of the reasons that I did it in the chat. Partly it was, we've always felt in TFOM, we found through the symposium when we thought about it that, you know, talks are really one-to-many. It's like, you know, you're standing on a platform and you're talking and everyone else is quiet. So if there's no interruptions, there's actually a really good chance to have this pre-recorded content. It's hard, it's a different skill set, but the other reason I did it was because I was like, my brain is not quite awake. I wanted to stay up so I would see all of the conference, but it was like 12 to 4 a.m. on the first day, and then it was 3:30 a.m. to now like 8 a.m. on the second day. So that was challenging. I mean, time zones are a huge issue with all of this. So pre-recording can help a little bit with that because I'm just enough awake to have a conversation with you now, but presenting the talk might have been a lot harder. So I think that helped a lot. I noticed that Natalie said in the chat that it's really hard to make time for it in the schedule. Yeah, it's super challenging, right? So especially in odd time zones, and we have this culture of just expecting to do online conferencing in addition to your day job. That's a cultural thing. That's something that we really have to address, you know, in our field. It has to be okay to make time, because if you went physically to a conference in another city or another country, you would have that space. You would be disconnected from your day job. So I think that's something we really need to build up robustness to and give people the space to do these things. We've talked about things, for example, like, you know, maybe you could go to a hotel just so you're disconnected from maybe your home life or your work life. After this, I'm going to sleep, and I'm going to sleep all of Friday. So the normal meetings that I might have, I'm not going to be there. And I've put that in my away message in my email. So yeah, it's a cultural thing. And those are actually the hardest things to change. But we're not doing this alone. You know, it's not an astronomy only problem. It's a world problem right now. And I think that's going to help us because everyone's thinking about it. And it's becoming it's a problem we have to solve. So there's a lot of people trying to solve it.
Yes, well, there are some comments about the benefits to have this kind of resource available. So, well, as many people is ready to go, I invite Santiago. I invite Santiago because we want to take the group photo, and I invite all the people to turn the cameras on if they want or they can. Yes. Santiago, you are there. So, well, thank you very much, all the speakers, because I believe the workshop was amazing. Probably tomorrow will be better, but until today is the best one. So thank you all for the time, for the effort beyond the workshop, for the effort through your work in inclusion and trying to make astronomy accessible, diverse, and a source for equity. So, Santiago?
Yes. Yeah, thank you very much, Beatriz. I have already taken one screenshot, but if you want, I can take more. So just say hello if you want, or anything you want to do. Okay.
Turn the cameras on, please.
Yes, I'm getting the screenshots done here. So thank you very much, Beatriz. I agree with you. It's been a fantastic workshop. I can tell you that we had 20 conferences. We have 4 invited main conferences. We have 12 different countries participating in the conferences, but we have like at least 30 different countries being registered, at least with one participant in this conference. So I think it's been really, really fantastic. This is actually above our expectations. Thank you for being part of this dream, because I think this is a dream of making science, and in particular astronomy, more accessible for everyone. And it's a real motivation to have many people here interested in the same, in planning how to do astronomy more accessible. So this is very encouraging, and I hope we can all see together again in person, probably in the version number 3 of this workshop, hopefully in any place of the world. So thanks, Nicolas, who is also here, part of the SOC, Gary, Silvina, also here, part of the LOC. Thank you very much for doing all your efforts to make this possible. I don't know if any of you want to say something. It will be very nice to hear if you have had a nice experience as we did. So I open the session if you want to share any thoughts, any experiences. So just to say goodbye and see you next time. Anyone? Okay. Ines, bye-bye. Juan Pablo from Colombia, thanks for joining. Please remember that we will have the conference proceedings. So you will receive an email so that we have all the instructions on how to present these proceedings. The deadline is going to be in a couple of months, so you will have 8 weeks to prepare your proceedings, and they will be published into the Revista Mexicana de Astronomía y Astrofísica. That's also very nice because probably is one of the first times that we will be able to have all these works published, and it will be a great idea for others to get interested in the topic. So we are actually getting the mass of people interested in astronomy for inclusion stronger, and thanks for doing that. So on behalf of all the LOC and the SOC, it's been a pleasure having spent with you all these 10 hours as a whole. Tomorrow we will have the video, so if you want to share the workshop, you can do it starting from tomorrow. If you go to the webpage, you will have the 2 sessions together in one video, so that many people can be interested in what we have shown here. Thank you very much. I don't have anything more to add, so thanks for being here and participating in this conference. Beatriz, thank you.
Thank you, Santiago. You were behind the cameras. And thank you very much because all your work. Yes, you are the chair finally. Thank you.
Okay, so thanks from our side. All the best and have a good sleep and have a good day in Australia, Vanessa. Sorry for, you are going to sleep as well. So bye-bye.
Bye-bye. Bye-bye, everyone. Thank you. Okay.
Okay, so we are